right, if you want to use the computer that's sitting in front of you, log in with this. You want to use your own device, this one here. You shoot me an email real quick. Email you the PowerPoint so that you can click on the things that we're going along. The things we're practicing, we'll use these sites and applications here. We'll get started in a few minutes.
Where do we go for Cisco? Just the idea.
Somebody gave me, you should go to their website and log in. There's a link on the top of the PowerPoint. It's right there. You know, we did it. The reason I said we had to do an account, but somebody showed me one yesterday where you didn't have to use the account and another one on the site. So it should be on the PowerPoint as well. Please don't forget to sign in. Looks like only 4 people are here. Also, if you know anybody that is missing out on this exciting adventure, I am tempted to live stream this. And it'll be available on YouTube after I get done. The whole thing will be available initially, then I'll cut it down and make it more manageable as far as bite-sized pieces and cutting out a lot of my unnecessary talking. And that'll be available after. I believe we may offer it on C-Turn and Harley Show. It works before we go from there as well. So you can review and go back and look and hear all the questions and things like that. It's a little chilly. I turned the knob to warmer is what the knob says, but I did that yesterday. It didn't get a whole lot for us, so hopefully you go out to target. Yeah, we'll use job. Although I do this in the future, I mean, problem is that the APCSA is still Java based. Hopefully they switch it to Python soon, but not yet. Yes, they'll have to keep up with the industry. Like the majority of the universities are switching to Java as their basic language to teach. I mean, they're switching to Python as their basic language to teach. Georgia Tech has, and engineering has, basic coding now. The basic level is Python. So the college board is going there to keep on pace with them. It'll take longer because education is slow.
Do you think they put more to work colleges are doing versus recreation?
College board? Yes, what colleges are doing. I think we have to one pathway assessments to adapt to an industry.
What was the Raspberry Pi? It's almost all Python.
Yeah. And it's a great tool to use in the classroom. So I can pull your desk up here. Okay. I'm looking for you. Thanks.
Further now, Vermont. Further now, Vermont. our workers more for my last.
All the insurance and medical, you cover your whole lot.
Cameras, lights, sign, LEDs.
That's impressive. It's great. We're gonna have to go video some of it on. Hello? On the roster.
Good morning.
Get the sign in, ladies.
Okay. Good morning. How you doing? Good morning.
Couple of minutes. So, you signing already?
Yes.
You gotta step on the side, it's taken up.
Don Madden?
Don, email it.
Is there a Don in here? Don Squires. You got a PowerPoint already? You can always send it again.
Yeah, it's just log in, it's there.
All right, so once more for the newcomers, if you're logging into the computer where you're sitting, use this login. If you're using your own device, use this one. If you go ahead and email me real quick, I will send you, well, somebody will send you the PowerPoint so that you follow along and click on the stuff that you're clicking on. Yesterday, we started developing a list of resources, curricular resources, so if you want to have anything you want to add to this list, start to think about that. We can put that up here as well if you want to start to jot this list down. There's stuff I've looked at personally and I found very useful as a teacher yesterday. found some of it very useful as well. Yeah, pictures.
I just don't-
Got it, got it.
So, let's see, let's start off with like a real quick poll. First, where are we from? How many people from, who travels by us?
Cherokee
Cherokee County?
Barstow County.
Bartow County? Same area. Anybody from Henry?
Fulton.
Fulton? Nice.
Right.
Where?
Right.
True? Nice. My father's from True.
Oh, really?
Rain Shores, yeah.
Okay.
Go there every year.
I teach at LaGrange High School, but all my family pretty much went to Truett High School, but you know, hey,
Yeah, I see that.
it's all good.
What conflict of interest there. Brooks. Nice. That's a nice little hike. Enjoying the weather up here. So, okay, let's also get a temperature. How many of you all have been teaching computer science for some time? Like more than 3 years? Yes, yes. That's good. Yeah. That's good. So, the purpose of this class is to provide a refresher for new teachers, or teachers that are recently new teachers to computer science, to give you all some of the basics, let you know what types of topics will be covered in a lot of the courses you'll be teaching. Also, the topics will be covered on the upcoming days, and things like that. So it's a refresher. If you've never ever seen computer science before, this might move a little faster than what you're comfortable with. If you've just been kind of exposed, it's probably perfect for you. If you have a long history of computer science degree and 8 years in industry, then you'll probably be bored. So, as is often the case with our classes, it's difficult to teach to higher end students, it's difficult to teach to those who are just getting there and just learning the concepts. We teach to the group that can get the most out of it. So, hopefully I'm talking to those people. Let's see if there's some housekeeping real quick. I'm sure many of you all have heard about the certification that is required for the upper level computer science courses. It's due by 2018. What's your question?
If we have 2 more terms, because I'm gonna start teaching the computer science pathway, just easing into it next year with IDT, and then adding on, and I wouldn't have to, but I said I would if I needed to.
Okay, so you will eventually. IDT, we were able to exempt from that list, so we don't need it for IDT or web design, I believe. But for the upper level courses, the principles, the
Yeah, we're gonna have.
CSA, we need it for the
I've heard rumors that they're going to start taking out business and computer science at middle school, or phasing out that pathway. You heard anything about that?
We're working on redesigning the computer science curriculum in middle school. So,
But you would let us know, right?
yes, I'll definitely let you know. And we'll open up some stronger communication channels today. So, junior.
Since 2018, school year?
Yes, 18, 19 school. So the summer of 18, next summer is when the business certifications expire for computer science, for the upload computer science course.
So, general question about this is kind of two, 3-part question. I've been teaching computer science for 10 years. I was in the industry too. And I took a little practice test that came out with it. Didn't do real well. I was lazy. There are questions on there about big O and algorithms and stuff like that aren't part of the standards that we're teaching. So the question only becomes, why are we having to certify on the questions that aren't part of the tests?
A lot of those questions will still end up on the AP test, HBCSA.
A lot of them.
Also, the current test is it's an add-on certification, and they're working on doing an initial certification. I think the PSC just finished their process maybe this month. So pretty soon we'll see an initial certification that will probably have taken more time to develop. This one was kind of a rush. It's only been available for a year and a half now. The rush to put it out. It was, I talked about the live stream wasn't here. It was largely taken from the Texas practices. So we just kind of took it and adopted it a little bit of our own. So as we move forward, we'll be generating our own case and taking a closer look at what exactly is required on the exams. I'm already having a strong conversation with the PSC about that. They also just finished doing the preparations for a national practice, which took more time to develop and things like that. So it'll probably change. It'll probably change in the next 2 or 3 years, but probably don't want to wait. You're going to be teaching year after next. If I want to go ahead and get started and prepare, most of the material will be the same. I'll talk about the big old stuff on here. And the sources and searches and sorts and searches and sorts and things like that. So I won't be able to cover everything, but I'll be able to hit a lot of the key points. And some of the stuff I cover probably might not see, but my intention is twofold. It's one, to prepare you all for whatever testing you're going to go through, if you're going to do the endorsement or take the case or whatever. It's also to prepare you all to teach computer science in a robust fashion so that the students can be prepared to do computer science. So that's my intention. We'll see that. I'm really good at that. Any other questions? All right, so we get started. Yes. Didn't get email. Don.Squires. Mind, would you see a Don.Squires at Gmail? Would you send me
It's not conformed to the internet.
All right, so this is a foundation refresher course. If I lose my keyboard, because I put this down all the time, if somebody please notify me where it is. It's easier to click here than it is up there. So this is a refresher course. We're going to start with the broad scope of what computer science is and how to approach it as far as an industry perspective, and then get continually more granular as we go on. All right? So start with some software design basics. Like many other disciplines, there's a design life cycle. It's very similar to the life cycle of a business, or like the engineering design life cycle, or any of these other life cycles that we've heard about or experienced in our life. Starts off with analyzing user requirements, finding the problem, examining what the problem is. So that's the beginning, is having something to do. Sometimes we're told what the problem is and what we need to do. So starts with that process. Then the design of the program. That's not the coding. The design portion is when you kind of think out loud. So a lot of you all are business teachers, you use the flow chart to kind of organize the concept of the flow of business or how the pathway is going to move through. So we use flow chart, we also use pseudocode to kind of organize our ideas and our thoughts before we go into the actual coding process. That's important to stress with your students. Before they sit down and code, they think about the logic of it. Think about what you want to accomplish and how you're going to accomplish it, and draw it up in a real simple fashion. We'll see some examples of that. Then you go into implementing the code. That's the actual program. You sit down and go into your coding environment, and whether you're typing Java or Python or whatever language you're using. Test the program is a really important part of software development. Make sure that it works before you put it out there. Sometimes companies use the public as guinea pigs to do their testing for them. And then they go back and redesign, which is where the maintenance comes in. You might say, put out a software application, something like that, or an app. And then when somebody gives you some feedback, some negative feedback, then you go back and fix that, and then it gets better as it goes along. So they're always, it's an iterative process. Then there's always updates. I get updates for stuff every morning. All right, there are a couple of design strategies to complement the software design process, software development process. There's top-down and there's bottom-up, and then there's object-oriented design, which kind of encompasses both of these. All right, so I got some bullet points up here, and I'll just touch on the key aspects of it that let you know what this one is about. So like top-down is uses a lot of decomposition. And that's an important word in regards to computational thinking. That's one of the key terms of computational thinking is being able to decompose a problem. It's break it apart into its smaller portions. Right? So top down means take a large problem, break it apart into smaller problems, solve those small problems, and then bring them back together as a cohesive whole. Right? Good morning. Good morning. Good morning. Get a sign in, but you can do that another time. So top down, decompose the problem into its separate parts, bring it back together into a cohesive whole, and hopefully that will solve the problem that you're looking for. Whereas bottom up, you start with some pre-existing, already designed modules. So a lot of coding. You don't have to reinvent the wheel. Some of the solutions to the algorithm that you're trying to address are already created. Sometimes the programmer himself or herself has already created the solution. I've already done this particular loop or this particular, I already know how to count from here to here. I'll just take that from my older program and add it to my new program. And a lot of times we piecemeal things together to create a better solution. So bottom up means we start with some pre-existing modules, put them together to create a cohesive whole. An object-oriented design kind of overlaps both. Now, the majority of the programming languages that we see in use today are object-oriented design programs, or programming languages. Majority languages. So Java, C++, C#, Python. These are all object-oriented design programming languages. There still exists some that are not in the world, like they are in the natural environment, and consequently you may be called upon to maintain them. But you probably won't design any new programs in anything of an object-oriented design, at least for the foreseeable future. All right. We'll talk more about what makes something object-oriented design. Clearly, it's the fact that there are objects involved. Everything in the world is an object. The computer is an object, the person is an object, the cup is an object, the bag is an object, the room is an object, the clouds are an object. Object-oriented design is about defining those objects and how those objects interact with each other. Right, so that's all it is. And there are different ways to define the objects and talk about their attributes and what they can do. And then what they can do helps them interact with one another. We'll talk more about that. All right, so some of the visual organizers I talked about earlier. A lot of you are probably familiar with the flowchart, so helping to walk through your logic of your program. Start, go through some processing, maybe some conditionals or something like that, and end up with a completed process. This is unified modeling language. Sometimes I'll say things a little bit louder so that you can hear them clearly and know that the vocabulary word is important. Unified modeling language. It kind of defines the objects. So again, we're not getting into a whole lot of detail at this point. We're just kind of giving an idea of what the object is. It's the customer. The customer has some attributes to it. Customer ID, customer name, and address, phone number. It has some things that it can do. You can add a customer, you can edit a customer, you can delete a customer. Customers interact with the order. The order has attributes. It has an order ID, connects to the customer ID, the product ID, the amount. It has things that it can do. So each one of these is an object. Each one has attributes. Each one has things that it can do, which we often call methods or functions. All right, there are 4 software development models. I attempted to highlight the pros and cons and touch on the key concepts so that you can identify one versus the other. The first one is the waterfall. The waterfall follows the software development lifecycle sequentially, very smoothly. It's a very traditional model that says first analyze the problem, then design the solution to the problem, then implement that solution to the problem, then test the solution to the problem, then maintain the problems. Sequential, it goes in order. Waterfall. It's a little rigid, not a whole lot of flexibility in that, but some business owners and professionals like that, like the structure. The incremental does the same thing, but it does that process in chunks. Right? So after each chunk, it might take a second and look at that chunk. So after you design the problem, you might come up with a bunch of different designs. And look at each design, come up with a solution. After you implement the problem, you may have to have another pause before you go on with the next one. So it does the same thing, but in phases. If that makes any sense. Right? Incremental. Requires good planning and design work effectively. Then we get a little bit more loopy. So move on to Agile, which is extremely flexible. Here's some examples of Agile development models. It's flexible because it does rapid iteration. If you have any app on your phone that gives you an update every day and a half, they're probably using an Agile model. They probably had something they wanted to put in the original one, but didn't have time. So we're gonna put it on the update, and we made another one, and we're gonna put that on the next update. And so it's more about speed, all right, which is why it's called Agile. Extremely flexible, can be prone to feature creep, which means you might end up paying a lot because you have to go back and redesign to put a new thing on that you could have put in the first place. So there's that as a possible shortcoming or pitfall for Agile. The last one, Spiral, is similar, but not as much. It goes through the process, but it makes a strong use of prototyping. So at each stage, you might have a prototype that it puts out to see if this is working the way you want it to. And then it'll go back and put something else into the prototype. So the prototype may not be the finished product. A lot of times you have people that are beta testers that will test the prototype to see if the features that we have in here so far are effective and useful. So those are our 4 versions. This is a vocabulary list. It's an important word. I should have bolded them, but that'll happen in the next feature. Robust, of course, we want to make robust programs that are capable of handling for conditions, for inputs. We'll talk about some of it down here, but as a programmer, you definitely want to think like a chess master. You want to start thinking ahead of what's the next possible iteration, what's the next move, what could go wrong, who might be using my program. That helps you make a better design. So it helps you create a more robust program, right? A unit test. Unit test is when you're testing each portion of your program. You can test a particular loop that you created to see if it worked well. You can test a particular module or a method that you created. See. You can test a particular module you've created that's not the whole program, but a portion of it. So you want to test a unit of it to make sure that it works well. So for instance, we're all working on a program together. You might be working on the user interface. You might be working on the database in the background. You might be working on some of the interaction between the players if it's a game. You want to test your portion to make sure it works. You want to test your portion to make sure it works. You want to test yours to make sure it works. These are each units that we're testing before we put them all together and put something wonderful into the world. Input protection and data validation is important because our programs are designed to take certain types of input. You might want to, I'm sure you all logged into something, and it told you that, if you were trying to log into the Cisco thing, and it told you that you need a capital letter, or a special character, or an underscore, or something like that. That's data validation. They're telling you that the data you put in doesn't match with our requirements. And sometimes you'll put in a character when it needs to be a number, things like that. So you have to think about that in regards to user issues. Things falling out of data validation or that aren't protected well can create exceptions. These are errors in runtime. So when the program's running and something happens that you didn't expect to happen, that can create an error. And sometimes they'll pull an error up on your screen and say, hey, there's an exception here. We don't know what to do with this. We're going to shut down. So that's, again, programmers need to be chess masters. They need to think ahead. What are the possible errors? What are all the possible inputs that somebody could put in? And incidentally, hackers do the same thing. I don't know if you've ever been to Google.com, where it's G-O-G-G-L, because they know that some people are going to make a mistake. We'll type it in Google, and they'll end up in our site, whatever we want. So there are things like that. So people think ahead about what could be a possible input and address that. So when programmers address that ahead of time, that's called exception handling. It's a programmer that's thought ahead, figured out what could possibly go wrong, what could be the problem, and address that problem in their program. So if the person puts in a letter, give them this message instead of a number. If a person doesn't put in a special character, give them this message. If they type too many backspaces, give them this message. So that's exception handling. If something goes wrong that wasn't supposed to go wrong, and you want to still get the program still be able to run, then you take care of some exception handling along the way. All right, time for quiz. Let's break things up. So I'm sure some of you all use Kahoot. Yesterday was my first time using it in an instructional environment, so you know where to go. Just type in Kahoot and it'll bring you to the right place. And this one hopefully will take me to the right, there we go. I love it first. All right, you just walked in. You log into the computer with this or to your own device with this. And if you send an email to me, my lovely assistant over here will send you the PowerPoint. You can follow along. There we go. All right, so your number to type in is 672-810. Judge, what's your naughty nicknames? Watch what you put in the computer. It's not be appropriate. Or you kicked out. No, okay. I'll correct that in the next iteration. Don't click on my link. Click on go type Kahoot into your browser and to the website. Hello, good morning. Morning. Tiger Mom. Tiger cousin. I got some cousins. 20, number 316, number 10. 10 more here. 4 people might be daydreaming. I know 2 just came in. Go ahead and start and then everybody still log in? Wait on anybody? One more? Okay. There we go. Listen.
Type the number where it says, when it goes there.
No, you tried to.
Just click the line. Right. That sounds like a good round. Software design basics, which is not a part of the software development lifecycle. Not a part. 30 seconds. Retrain, yes, good job. Nice. It's a great class. I like this class. Analyze definitely the first stage, and maintain is very, very important final stage. A lot of the programs will be doing is maintain. The strategy relies on pre-existing methods to construct a solution to a given problem. Bottom up. Yes. Very nice. So the top down, that does the decomposition. I mean, that's when you take the problem and break it apart into smaller parts. Bottom up is when you find already pre-existing modules and put them together. Object-oriented design, while it encompasses both of those, it's not specifically geared towards that. Could be the right answer. All right. Which development model follows the software design cycle, life cycle sequentially? which color your eyes go to. I know that they said that people's eyes automatically go to red one. Nobody chose red for that. Very nice. All right. Agile is a good answer because it does go through sequentially, but it does it in chunks, whereas the waterfall just goes through it steps. Underlying concepts of object-oriented programming include all of these except, this is interesting, we're going to talk about this yet. Nice little pretest. Object-oriented programming include all of these except security. Good job. That's nice. Talk about it again. So while security is a very important aspect of coding in our world today, it's not an underlying concept of object-oriented programming. Inheritance, abstraction, and polymorphism are. Polymorphism is very important. We'll talk about that in just a second. All right, last one. Which type of polymorphism refers to writing multiple methods with the same name. Again, pretest stuff. This is. Writing multiple methods with the same name. That one of those long beard. Overloading, yes, nice job. Nice. And overriding would be the next best guess. Nice work. So we'll do that in just a second. All right. Nice.
Scoreboard.
Oh, scoreboard, sorry. See the scoreboard, I apologize. Better, good job, who's better? Better, good job. Actually, better. You're better as well?
Yeah, but I think she's.
The other better. And then Linda, Linda.com. I love the website, it's fantastic. And Tonomics. Is that correct, little boy? Tonomics, what's Tonomics?
That's my company's name.
What's your company's name? That's how you advertise right there. Everybody sees Tonomics, right? All right. Look back here. All right, so object-oriented programming. I'll get into some of that stuff today. That's all. What is object-oriented programming? I'll talk about that more. But these two are very important aspects of object-oriented programming. Objects and classes. And we'll distinguish between the two in a minute. As I said, most of the languages that are being written today are object-oriented. They may be imperative, which means that the problem or a need is driving it, or they may be functional, meaning that the function of the program is driving the design. And I think I have these definitions. I don't have them. They're on the notes here. They're on the notes here. So what's imperative? Let's say procedural programming paradigm. The developer writes code to describe the design in detail, the steps the computer was taking to accomplish the goal. What about functional? Pure functional approaches problem solving. So, sounds similar, but it's more procedural and it's more not functional aspect. Objects and classes. And again, I'll get into this later on, but a class, anybody know what a class is? Can you give us a good definition how to differentiate between those two things?
So class is something that applies and has both methods and variables.
It's true. How is that different from an object?
Object is instantiation of class.
Object is instantiation of class. So class is a general definition or general description. An object is a specific version of that particular class. So the example I normally give in class, what I used to give several years ago on the time science, is like a student might be a class. That would be an object that's instantiated of the student class. So that's a specific object. The class is a general description. The student class might have a name, date of birth, grade. That's attributes of the student class. Beth actually has the name Beth. What grade she's in, date of birth was yesterday, and all the different attributes that go along with that particular student. So object is a overall And no, class is the one, so general description and object specific instance. Encapsulation and abstraction. So I'll do abstraction first. One of the key aspects of object-oriented programming, or programming in general, is abstraction. We have students, we have cars, we have things in the real world that exist. In order to create a program that deals with those things, we have to create an abstract version of those things. So you have a student sitting in your class right now, but on your computer, you also have this version of that student there that can do certain things and has attributes, and you can do things with this abstract version of this real life student. Right? So one of the powers of programming, one of the powers of software development and design is the ability to abstract real world things into a software environment so that we can do things with it. A student in the software environment can do wonderful things. They can do backflips and all kind of stuff. Real students, yeah, sometimes they can do backflips, sometimes they can't. So abstraction gives us a lot of ability. Encapsulation is another powerful tool because it hides a lot of what we're doing. It creates so a class has a lot of stuff written into it. It has all the attributes of that particular student. It has all the things that student can do that are methods. And the administrator may be able to see what all the things that student can do. The teacher might be able to see what all the student can do. The janitor may not need to see all of that. They can see all the things. And even the council administrator, they don't see the class itself. They don't see all of the gobbledygook that goes into our programming language. They just know that the student can be enrolled and released. So they don't see all the stuff. They just see the student. That's encapsulation. We just see the outer pretty container. We don't see all the stuff that's inside. All right. That's a very powerful aspect of the object-oriented program. All right. So these are the three concepts. We just talked about abstraction, how powerful that is, and how important that is in regards to thinking about coding, thinking about programming, being able to extract things from the real world and find a representation for them in this box. Inheritance and polymorphism are the two other key components of object-oriented programming. Inheritance means that you can have a class, a general class like, we'll call it personnel. The personnel class might have an ID. It might have a role, that person's role. It might have a date of birth. Another class that you pull from the personnel class might be the student, or the administrator, or the teacher, or the staff member. These are all personnel, but they all have their own classes as well. So the student class will inherit things from the personnel class. It will also have an ID and a role. Its role will be student. We'll also have a name and a gender, just like all the same stuff from the personnel class. But it will also have its own stuff that's specific to the student class. So just like your children may inherit some things from you, some things you don't necessarily want them to inherit, and some things that you do. The child class inherits things from the parent class. And then, of course, it adds its own things to make it more specific. Right? The teacher class also inherits from the personnel class. The administrator class inherits from the personnel class. All the child classes of the personnel class get something from there. Right? Composition is when a particular child class inherits from more than one parent class. Right? So, so we use our same example. You might have personnel, and you also might have employee. So the student will inherit from personnel, but they're not going to inherit from employee. Whereas the teacher will inherit from personnel and employee. Employee has other stuff that goes along with it. The administrator also inherits from personnel and employee, as is the staff member. The student only has that one parent. So compositions, when you get things from multiple parent classes. This can be very useful. All right, polymorphism. We said that an object or class, an object has things that we know about it, attributes, and things that it can do. We often call them methods, right? So polymorphism is a very cool way to address some of those methods. One of the ways is overloading. You might have a method within the student class that has the same name as another method within that student class. This often happens with constructors. The difference being, so if I had a student class, right, and we have some attributes, name, date of birth, and then you had a method. The constructor method is also called student. We'll have the same name, because this constructor will create an instance of a student class, right? But this one is just a regular student, so we just create a general student. I might also have an instructor that creates a CTAE student that takes in their department. So now I'm creating a student who I know is taking some of our courses. And well, I'm passing them what course they're taking, either business pathway or the computer science pathway. But these two methods are both within the student class, have the same name, and do pretty much the same thing, except this one takes different information. That's called overloading. So we have one method, two methods, three methods, sometimes 4 or 5 that have the same name. That's overloading method. All right. Overriding method is when the student inherits something from the parent, inherits a method or something they can do from the parent, but then you want the student's way of doing that thing to be a little bit different. So you rewrite that method. It may have the same name, it may be drops out. All the personnel can drop out, but when the student drops out, it means something different than if the teacher drops out. All right, so we want to write it a little bit different. We want to create it. That's overriding. It means I'm going to take the method that I got in personnel, I'm still going to use it, but I'm going to tailor it to the child. Sometimes your children inherit some things from you and then they change it a little bit. You might have been a mathematician, and they take it and become a computer scientist. It's the same analytical thinking, but they've overridden that to create their own scenario. All right, polymorphic objects are objects that need to be able to address other objects in their inherited level. That's going to happen again in a couple minutes. There's the late bell will be around short. So, for instance, if the administrator needs to be able to access the personnel class, that's something that might need to happen. So they need to be able to access all aspects of the student and the staff and the teacher. So if a child class can access the parent class, then that's a polymorphic object. All right, so the access going in different directions defines what a polymorphic object is. All right. I don't get too heavily into computer architecture, but it is something you should probably know, at least the definitions of some of these things. It refers to stuff going on inside the box and how it operates and which ways it goes. So for instance, like the instruction set architecture is how the computer deals with instructions. So it includes the bus, the registers, and all the different ways of memory. So how the information moves from an input device through RAM, across the bus and into the register so that the processor can do something with it, right? So the instruction set, or instruction set architecture deals with those things. If you're buying a computer and you look and want to see how fast the bus is, if you really get into the granularity of the performance of the computer, that matters. I don't pay that much attention to it, but I know that it exists. Complex instruction sets versus reduced instruction sets. One promotes coding efficiency, and one promotes processor efficiency. So this is how that little brain inside the computer, the processor, works. Right? One of them makes it easier for programmers to do things with the processor. Others make it easier for the processor to do things. And it really is a matter of philosophy as far as which one you want to go with. Intel tends to use the complex instruction set, versus Apple tends to use the reduced instruction set. So I can't really tell which one is better. I don't know. Depends on the application. All right, operating systems. So we talked about programs and what they are. Well, an operating system is a program. It just happens to have a specific function. It serves as a platform for other programs. Some operating systems, like DOS and original Unix, are command line based, which means you don't see the pictures, there's no icons, there's no menus, there's no desktop you can look at. It's just a cursor sitting on the screen, believing that you telling you to do something important. So if you don't know what there is important to do, then it's just going to sit there and stare at you or tell you that you're in there. So command line operating systems, DOS and original Unix. The rest of those, Windows, Linux for the most part. There is a command line version and background to Linux, but there are some GUIs as well. They're called GUIs, or graphic user interfaces. Right? So they have icons, they have menus, they have desktop backgrounds. You can make a pretty thing on your monitor to look nice as you're doing your work. Like, so Windows, Mac OS, Android, iOS, those are all GUI-based operating systems. Touch briefly on our artificial intelligence. Anybody want to give a definition of what artificial intelligence is, or what their perspective is on artificial intelligence?
Machines being able to think for themselves.
See what?
Machines being able to think for themselves.
Think for themselves. Yes, they. Oh, you got to be careful. Say that becomes scary. You got to use more PC terms. Machines are responding to user inputs dynamically, so that they can come up with novel and new ways to approach the environment. If you think of themselves too close to being humans. But yeah, AI can almost seem reasonable in regards, and we've all seen some smaller, lower versions of AI. I don't know how many of you all have an Amazon Echo or Google Home that will listen to you, or how many of you all have used Khan Academy. So something simple, Khan Academy. Student gets on Khan, does some math problems. Khan comes back and says, hey, you need to spend more time practicing on this and less time on that. So that's the machine responding to user input. So that's a very low level of AI. Some other versions are like self-driving cars. The more people drive the self-driving cars, it sends information back to the main computer, and all the rest of the cars get better. So the more we use it, the better they'll get. That's a version of artificial intelligence. Video games that get harder as you go along, as you become a better player. We have some, I play video games with my guy kids, and there's some of the artificial characters in the game that will hear you rustle down the hall and stop and go the other way to sneak up behind you. That's a little scary, but it's artificial intelligence working in a gaming environment. And you just made it before the tardy bell, man. Good job. Smartphones also do artificial intelligence. My phone in the morning tells me how long it's going to take me to get to work before I even got out of bed. It tells me if there's weather issues or if there's an accident on I-20, and I don't even want to know that right now, but it does respond to the things that I do. Your students might use Pandora or some other music things that they use. Spotify, yeah, those things that pay attention to what you listen to, and then we'll create a playlist based on your previous inputs. So it's low level artificial intelligence, and it's going to get much more sophisticated within the next few years. All right, another tool. Log in with this. If you send me email, I'll send you the PowerPoint so that you can follow along. These are some things that we're working on. All right. Join it, almost. And there's another. Still wide. I'm going to edit my dancing out of the live stream later on. I'm not to worry about that. All right. More people are good. Software design basics 2. Which software development model is characterized by rapid iteration? One of them I said those exact words, rapid iteration. Agile. Nice work. So Agile definitely deals with rapid iteration. It puts out updates quickly and often. Now, incremental and spiral probably do some iterations as well, but not as rapidly as Agile. Agile is the word on itself, means quick. The only game. All right, we're software development model follows software design cycle in smaller fragments. So it's going to follow the cycle, but follow it in fragments, chunks. All right, nice job. So the waterfall follows it, but not so much fragmented. It just goes through and spiral. And then spirals, but the key idea for spiral, we'll see that. This one. Which operating system is command line based? DOS. Nice work. Now, maybe the two people that said Windows might have been thinking about the fact that Windows used to be built on top of DOS, because it was. A lot of operating systems were built on top of other operating systems. I think the new Mac is built on top of Linux. So it could be an option, but DOS is the only one that's completely command line based. Or was. I don't even know what it is. All right, Jay-Z's in the lead. Which is a key concept of computational thinking. Abstraction, yes. Nice work, nice work. While searching for underlying causes is a great thing to have in our life in the world, it's not necessarily a key component of computational thinking. Decisiveness is also important. We'll set aside for a person that knows what they want. Right, so abstraction. And that's one. Which type of polymorphism is defined as an inherited method being rewritten? Nice. Nice done. Overstanding is a word I got to a reggae song. Overloading is, what's overloading? It's what? Same name. Same name, yes. Multiple methods with the same name. And the results are Richard. Who's Richard? Good job, Richard. And JMR. JMR, nice work. I see you sitting back there behind the other two roomers. Pay attention to things like that. After the break, we're going to break you up. MBUZ. What's MBUZ?
My name is Melissa Busman, so I just use him Buzz.
I like it. I like him, Buzz. Good job. Work. Like those of us. Go to the back desk and clear everything. Still there. Quick. All right, let's take a quick 5-minute break. Think about things. We need to rest for a second.
I mean, I can see your name.
If you haven't signed in, please address this paper up here. I had a really nice Godot pen. You're welcome to keep it. You're welcome to keep it afterwards, but need something to sign in. Here. All of y'all, also, if I'm moving too fast or if there's something you want to stop and ask questions or something like that, please don't hesitate. This is a workshop for you. I'll talk about Dylan, why were you not winning this group?
Oh, man, that's more folks in here than I am. That's why. One thing, Brian, that I want to do this year is put together. Corey no longer working with us. Really, it's complicated and stressful. So that's why you haven't heard of him. And I've been trying to catch. And that's one reason why I'm trying to catch up and make sure I pick up on the great stuff. He doing some great work for me. Unfortunately, I no longer have him. I'm kind of short, so I don't know. And now my staff, I don't have anybody with the expertise that could lead the charge. So it will probably be me, just adding another thing to my plate. So Martin kind of filled me in. Martin, so he kind of filled me in. He's doing some workshops for me this summer. So
let me tap into something because I'm working with, Deepa, CSTA, President of CSTA. We're in contact recently. I'm probably talking to him tomorrow about doing some workshops. That combination of webinars and in-person workshops and that kind of stuff.
Yeah, my teachers keep running from this, man. Keep running from it. It's been about, well, I guess ever since, you left, I've been trying to help teachers to say, look, I need for you to, when it's coming, and now it's here. Now we're behind the egg ball. We don't have staff. And that's why we're using Tracy to kind of help us with TILs to try to put the support in place. But even with that, we still got folks not doing. I mean, this day teacher, they just I'm a little frustrated with my own because it's running from me. I understand.
People like to stick to what they know.
Yeah, but that ain't got nothing to do with us. We got kids that gotta be prepared, man. So you gotta put yourself. You gotta get yourself out of the loop. We gotta teach kids, man. We gotta be prepared. We're not. That's what's. I guess that's what I'm more concerned about. Their shortfall, but I tell them, just be patient. I'm not going to give you more work if we just learn a little bit at a time, and then we don't get there. We'll get there. Some of them they're running, and then my principals don't know. And
Those sometimes they have a lot of principals and counselors.
Principals, we don't start advertising. Start doing that. This year coming up, I'm going to do a lot of activities with elementary school. All the piece is my middle school working with them. Like Martin did with Block. He did doing we also did making Mickey with them on Monday. So we're gonna do more stuff, try to get them. So I want the kids, nothing else. If I get the kids interested, then it'll pull everybody else. Pull everybody else in. So she wants Oh, no.
We're gonna talk for a long time.
I started the NX. Yes, it looked very similar. But as I was going through it though, I got stuck along the way. Like I couldn't figure out some of the code, and so.
It didn't look real bad.
You know, if you don't have somebody there, I guess, to explain it, like, if you're not, that's fine. So I signed up for the spot class at All State University. Paid for class, it's supposed to start on July 12th next weekend. I was the only person who went, so they canceled me. I know, I'm heartbroken because I only taught IBT. Next year, I will teach CSP and programming language apps and society.
Check your back.
And so if I were to teach those classes, then I need to now pass this test. And
Don't say God is here already.
I would advise taking time on doesn't expire till next month.
I'm gonna take the time to because I own being.
One of the.
Yeah.
They might have a question.
A lot of times, yeah, I want to be able to don't stick to that. I want to make sure I understand what I'm actually doing. Plus, we'll come up with an excuse why we don't push the two songs down.
Well, make sure it's
That's what I did. Yeah, my teacher has man for it, my heart on and off. I would never forget it. I was all the way right back to next year.
I'll try to see Jamal if I can figure out. I don't. It's I go to the website.
Whatever thing we had to do. Just make sure you got all this stuff.
What you should be able to do more is trace code. To walk through some code and say, the output should be this. The output should be that.
Just make sure that's something I know as we were going through that class. I was like, this is not a standard, so that probably.
It really depends on you, because there's a cost factor and there's a number of companies. So teachers that have never ever seen anything in computer science before, I would recommend going to start on just because there's a series of information that builds. Yeah, 3 to 4, depending on when you take
What is it called?
Endorsement. depending on where you go. At Columbus, I believe it's 35, 35, something like that. And if you go to the Oconee Reese, they'll do 45, but they'll give a discount if you go as a group of teachers. So like you bring 3 or 4 of your teachers, then they'll discount.
So there's only 2 reasons, Columbia and
Well, Oconee is a Reese that way. Like Columbus State University, it's all the place to talk. Take away out.
Well, they were talking about, we did that code.org training all last year. And they were trying to see if that's gonna count towards it.
I emailed and asked about Bill.
Well, she said she was looking into it, but and all these people are saying something about your grandfather did, that everything could be changing.
No, although. So, famous certification. Now, use actually that. Lots of people. Out of the 183 districts in the state, only 3 of them are status quo. They decided to follow the state's mandates. Everybody else is in the charter, strategic way. And either of those options can waive certification. So you really got to talk to your district to see what their stance is on certification.
On the other one, you still teach out of field, but that's less than a percent. So you could probably take 3 IBT classes in your book and then 1 computer for 5 or 6. Quite around
They
it.
just do classes out of your area, is what ours district does.
So there are lots of loopholes, and you really got to go and talk to the district about what
No, it's just like,
certification.
Yeah, that's in the student.
We'll talk about some programs. All right, programming languages.
She won't cover endorsement passport days. You have to ask your building principal.
This is my normal call to attention. Talk to
I'm gonna write him a letter to tell him.
Go up. Headaches.
Hey, ask her again about that third level, EOPA, see if she responded.
CS50. I have no idea. I mean, I've looked at CS50 because the resource is pretty strong, but I don't know anything about Taylor. If you see the email, I can look at it. I'll see about it. But I don't know about it. All right, programming languages. As I've said, the majority of programming languages in the world today, that you're programming today, students programming today, object-oriented. Programming languages vary in complexity and distance from machine language, which is binary, the ones and zeros that the computer understands, to some programming languages, some of the newer ones, are actually vocal. You can talk, and it will tell the computer what to do in the programming verbally. So we're attempting to get as close to real language as possible as far as instructing the computer on what to do. Right now, we already tell, what's the Amazon's name? Echo, she has a name. Alexa, do X, Y, and Z. And she'll go and do X, Y, and Z. So we'll get to the point where we can talk to computers and have meaningful interactions where they can start to do things that normally we would do. Not quite there on the whole, but we're getting there. So object-oriented programming languages and high-level programming languages, as you type them, they sound like an actual language, which is why, I guess, computer science courses count for foreign language credit now. But admission into USG accounts for, if you take 2 of them, admission into USG accounts as a foreign language. Also,
Second and third level.
second and third level.
Yeah,
so-
IDT doesn't count.
Yeah, IDT. Yeah, it's the same list that counts for graduation credit. So the same, it's like 9 courses that count for your 4th science graduation credit, for I don't say math because they don't count for admission into USG with math. They count for graduation, but if you try to use that as a math to get into college, it's not going to work. So normally I just say science, I kind of leave math. Even though it does count for graduation with math, I don't say that too loud. But it does count also for the 4 language credit going in. There are or have been hundreds of languages used to create instruction sets, but they all ultimately have to go back to binary ones and zeros. Right? These are some of the types of the languages. Machine language, of course, is that binary ones and zeros. We'll talk briefly about that in a moment. Assembly language is a little bit higher than machine language. Most people don't program in assembly language. The majority of programmers don't program in assembly language. It's real, I don't know, cryptic. Cryptic, there we go. Good word, I like that. Very cryptic. So we don't use that as much. So in a lot of the languages, what they'll do is they'll go through a translation process. They'll translate your high-level language to assembly language, and from assembly language to binary. It all happens when you compile the program. You don't get to see it. It's just the one magical box that says do, and it creates an exe file. All right. Functional programming languages, procedural programming languages. Some do exist still. COBOL is designed for businesses. It's a procedural programming language. You don't really program in COBOL anymore, but you may be called on to support COBOL programming, some programmers. So if you know COBOL, then you can kind of write your own ticket because there aren't a whole lot of COBOL programmers in the world anymore. And it's a very difficult language. I had to take the class twice. It was ugly. It was just messy. A long time ago. Right. So most of the high-level languages that we deal with now are object-oriented programming languages. Now, we also want to mention the markup languages like HTML and things like that that will take a document or a digital file or something like that and change it slightly, put some tags on it to make it be able to be read by a browser or some other application. All right. So those are markup languages. Data types. Data is organized into types. There are several different types of data. Data can either be a primitive, which means that somebody created that particular data type, that class, a long time ago. And most languages use the primitives, the ints, the floats. We'll talk more about those specific in a minute. A class could also be considered a data type. A student is a type. It's a data type. It's a student type. But we normally refer to them as classes. So classes are broader data type, I guess, a more robust, something that a programmer that students will create. But so they come in different formats when writing code. I'm going to talk about the primitives. There are data types that have existed since time immemorial, since before the flood. There were these data types, and what we want to pay attention to, most of the high-level languages share data types, so int, floats, boolean, those type of things. They have particular uses, like an int is an integer, but so is a short and a long. Now, the difference being, and as a programmer, you want to pay attention to this, they take up different amounts of space in memory. All right, so if you want to save space, and you know that the data you're going to get in is either going to go from 0 to 9, then you only want to use a short, because you don't want to take up too much memory space. Now, 16 bits isn't a whole lot if you're doing something over, but if you do that over every time you run this program 100 times, that's a whole lot of wasted memory. If you do a long and you only need a short. So ints, shorts, and longs are all integer types, but ints are 32 bits, take up 32 bits of space. Shorts take up 16 bits, and longs take up 64 bits. Same thing with floats and doubles. These are both decimal types, both floating point numbers, which is a decimal, but float is smaller than a double. It's less memory. Char is a single character, A, lowercase a, capital A, takes up 16 bits. Strings take up much more. So a string I like to use as an example of a class that we didn't have to write because the string was written a long, long time ago, and we used it as a primitive data type, even though it's technically you could look at the string class and see all the attributes of strings and what you can do and all the methods and all that kind of stuff. So these are all data types. But this one looks more like a class. As a matter of fact, strings are even written with a capital S, like your classes are written. Whereas the other primitives are written with lowercase. It should be lowercase. The other primitives are written with lowercase. Boolean data type that can either be true or false, right? So after we know what data is, also very important, number bases. Now, number bases aren't often covered in math class, although they should be because it's very important for math class. It's also very important for computer science because we normally count in decimal, which is 10 digits, from 0 to 9, but computers only count in binary, which is 2 digits, 0 and 1. And the reason why computers only use the binary is because essentially they're electronic devices, and all they understand is whether the circuit is open or the circuit is closed. Either light is on or it's off. They can take that on-off sequence and create all kinds of things. They create Minecraft and the digital version of Star Wars, and I saw the Wonder Woman movie last week. It's great. So they can take those digital ones and zeros and create all kinds of stuff, right? But ultimately, all they understand is if the charge is on and the charge is off. Other relevant counting systems are the base 8 counting system, which is called octal, which that makes sense, octagons, and the base 16, which is hexadecimal. So, does anybody know how we get 16? How do we get 16? How do we have 16 digits? Right?
0 through 9, 8 through F.
0 to 9 and then 8 through F, right? So after you get to 9, then you start counting letters. 10 is A, 11 is B, so on and so forth, all the way up to F. So that's 16 digits for that counting system. All right, on your PowerPoint, there's a different link. Somebody showed me recently how to get to this game without having to log into Cisco. I was very upset. I used to use it all the time in my class. It's great. The kids love it. They used to come into the classroom and say, "Hey, can we play the binary game?" Yes, you can. Have a seat. Go ahead and get to it because they enjoy playing. So game and notifications is cool. So I, advise you to go ahead and take a second. But actually, do the Kahoot first. Then give some time in Cisco. Butter and jelly sandwiches. All these nicknames be weird. So if you want to use computer footage, you can log in here. You can use your device. You can use this. You send me an email up there. I can see the PowerPoint that you can click on. Okay. All right, that's 22. Do you need more? Waiting on anybody else? Good. All right. Yeah. Basic accounting is referred to as 20 seconds. That's going quick. Somebody was paying attention. Yeah. I know it's great. Octo. All right, fantastic. Decimal is base 10, binary is base 2. Board on the top of the scoreboard. The primitive data type for decimal numbers is called floats, floating point number. Ooh. Decimals are floating point numbers. Ints are integers. Ints just 1, 2, 3, 4, 5. Decimals are floats. And shorts are also integers. They're just really small integers. All right. We want to do that. All programming languages must eventually be translated into which language? Don't see your answer up here, so I'll do not the one.
What is this?
Machine language is correct. Nice job. Object-oriented language, most of our languages are object-oriented, but they all have to be translated back into binary. They all have to go down to machine language eventually, but you can understand. Java is an object-oriented language. It's still got to go to machine language. Procedural language, we don't like those anymore. They're hard. They make me take classes more than once. Also got to go to machine language. Everything has to go to binary. All paths lead to the ocean. How many bits are required to store an int? Which one was it? And a long beard. How many bits are required to 32? Nice job. Nice work. Nice work. Yeah. You ready, people? You got caught by my trick. I had a lot of work. H. Really strong. Question 5 out of 5. Who can convert that number into decimal? What do you get if you convert that 10011 to decimal? A lot of 19. There we go. Good job. Nice work. Would somebody care to come and show us how to do that, please? Somebody? Brave soul? Yes.
Add 16 to 1.
Can you add the stuff up top for those who don't know?
Sorry?
Go ahead.
The two exponent.
Oh, so 16 plus 2 plus 1. 16 to.
You put it here.
I put it down.
You put it below instead of on top of it.
Oh, okay.
So normally we see like this, where this is the 1, 2, 4, 8, 16, 32, 64, 128. What's the left 128? 56, 5, 12, 5, 12, 24, 48. Yes.
So what I was saying, because some students don't know how you're getting that, so I was saying to add, base 2 to the 0, 2 to the 1, 2 to the.
Oh, nice.
You didn't have to do it. I'm just.
Yeah, they say this is 2 to the 0,
Yeah.
2 to 1, 2 squared, 2 to the third, 2 to the
Yeah,
fourth,
so forth.
and so forth, right? That's what those come from. All right, take a couple of minutes and play that binary game, the Cisco binary game, where you'll be using this wonderful math right here.
Can you explain why I skipped, why I still got 19 now?
I got 19. Okay, so when we line this up and we use these numbers, this is where this falls in place. We only have a 1 in the 16 place, so we add 16. We have a 0 in the 8 place, so we need to add 8. We have a 0 in the 4's place, so we need to add 4. We have a 1 in the 2 place, so we need to add 2. And a 1 in the 1's place, we need to add 1. So normally what we do is we'll take it, I used to have my students line it up like this, and then put 1s and 0s underneath the places where they need to be. So if I do an octet, 4, 2, 16, 8, 4, 2, and 1. If I had a binary number of 1, 1, 0, 1, 0, I'll take it and just line it up under these numbers. And only add up the places that had a 1 under it. So if it was 0, 1, 0, 1, 1, I'll take a 16 plus 8 plus 2.
Okay, I got it. I wrote an extra 1.
Yes.
Got it, thank you.
There in code.org,
Yes.
they have what's called Flippy Do. And if you Google Flippy Do and go to code.org, My kids love this, and they still talk about binary and the flippy do. So it made it really easy to learn how to use binary.
What we do?
Flippy do,
It's a chart that allows.
L-I-P-P-Y,
yes,
T-O.
Dio. Or converting it from binary. Oh.
Get rid of that second link. First one, second one, jump to first. That one probably have to create it too. So look at the first one.
I think I did.
The other key to doing students on binary is that that very first digit is a 1. It has to be a odd number. So if they've gone through their translation, it's not odd. That's the 1 they do it.
Everybody hear that? Quick check. You go binary. You look at the last digit. The last digit is a 1, then your answer should be odd. So that's like an after check. If you've done your numbers and you got an even number, but this is 1 here, then you did something wrong. Yesterday, somebody asked these codes were publicly available. Yes, they are. They're on PowerPoint. You can click on them and use them if you like. Oh, this is okay. Sometimes that's
Are you really? What do you mean?
Taking a look at that.
Oh, yeah.
It's just. So this is
started that. And what they told us, they said, it's too long. So, really, the master knows. So, it's account. And I started. So, I had to do here. Do well, last fall. That's all fine.
Give a couple more minutes for the game, then we'll do one more section before we break for lunch. How's everybody feeling? Am I moving too fast? Am I moving too slow? Is it over your head? Is it under your belt? Is it like where? Okay? It's good?
What's the name of the case that we have to say?
That's called computer science.
I'm just trying to find like in their it's on record.
I heard something interesting this time.
This guy.
I said that, yeah, they didn't see another offer. It's June. I'm assuming they have some.
Because I want to change it to file.
I feel like we have some in the fall. I don't know if they have yet, but
Will that help a lot? Preparation.
Yeah, they'll tell you what the categories are, but
I have all the information from
Yeah,
the that class.
that's gonna be all that stuff.
Okay.
All you need. And some of the stuff that wasn't in that class, that I feel you may need to review, like logic gates, hardware. I have some, I'll touch on that just kind of at the end.
Okay.
But just give you a heads up to say, you should probably know what a peripheral device is.
Okay.
And what a bus is. And what the logic gate is for exclusive.
Sorry, I have these trouble with the
We'll
connection.
do that.
Is it multiple choice or that's the whole test?
How many? Like 100. Yeah, I think something like that.
Well, these days, one check business days, we didn't have to do my days. And now it's all online.
Are there different levels of passing? Are they
Yes.
requiring a certain level of stuff?
I think right now,
Things like
the
tax.
nominal level is. So there's like, it's called, and then there's a professional level. As long as you pass this level, you're good. Yeah, I think the professional level is like 70.
So that's how I can score that.
Stop it.
It would be like the students. Like, oh, I can say, probably that's.
All right, so let's see, what is this stuff called? Program fundamental. Let's start with this, and then we'll stop with this. All right, so programming fundamentals. Now we're getting a little bit more grainy. We're getting a little bit more detail oriented. We're going to get more and more detail oriented as we go on with the day. All right, so programming fundamentals. There are three basic control structures used to direct the flow of processing when you're dealing with computer code, right? The first one is called sequential processing. Very, very simple. It means that this happens and then this happens and then this happens and then this happens and then this happens. Happens in a sequence. It's very linear, right? So that one, no problem at all. Execute things in order. This is when things start to get a little fun. Conditional processing. All right. This is your traditional if-else statements. If this happens, then that creates a binary track at least. So if it's rainy outside, then I'll take an umbrella. If it's not, then I'm not bringing my umbrella. I'm not wasting the space, and I'm not going to hold it and do all that kind of stuff. So if-else statements. Now you can combine these to make them more complex. So you can combine an if-else to make it if this, then do that. Else if this, then do that. Else if this, then do that. You can have multiple nested conditionals, right? And you can also use conditionals to create multi-case conditionals. You can also use that if-else thing to create multi-case in case. So if you have a score above a 90, you get an A. Score between an 89 and 80, you get a B. Score between a 79 and a 70, you get a C. Do they do B still? Yeah, you get a D from 70 is a D. I don't really know what that means. It means you passed, I guess. Apparently, the teacher likes you a lot.
You can do the work with you in class.
Yes, there we go. All right, so we can create some multi-way conditionals as well. So we're leveling our if-else statements. So that's conditions. I'll show you this. And we'll do here the last one when we come back on our lunch break. Something to it. Let's practice. And this, I would say. So I put Khan up here because it's a growing and improving resource. When it first started, it was very shallow as far as computer science was concerned, but it's continued to develop. I like that. It's a challenge. So I want everybody go on a bouncy ball and see if you can create an if-else statement. So here's, you got a hint up here in the corner that will make the ball bounce back up. Right now, if you do the ball, you just start, you can see it. You start, the ball goes down the screen, and then goes off the screen. Oh, let's mic this. Let's refresh this. Okay, attention to the answers. Still there.
Line 14.
Yep. Delete that. There we go. Now, ball should go and keep going and go on forever and ever and ever. So once you create an if or if-else statement or if statement, conditional, that will have the ball bounce back up. All right. So try that. Let you go along and hold all of this.
It worked on ours, I mean, it did work on ours, but properly. Right. It did what it was on.
It was designed to
Yes,
not
yes,
which one it's which.
yes. The example was proper.
So I'm using this to contrast something else, and I'll talk about it after we do the next exercise.
That's pretty fast.
That might be good.
See your wife do start up and do So they're
Right.
So anybody got the ball to bounce?
Well, this supposed to go down in front of my
Yep. I can do it on there.
Then they
Oh, yeah. Come click there. Oh, thank you.
Oh, those.
Okay.
And bounce back down. Good job. Thank you very much. So how did you guess, or how'd you get to 365?
Well, in code.org, we had a little thing where it had a square and you had to memorize. It was around 360. So I had 360 at first and it was slightly close. So then I went to 5 increments of 5 to see where I was off
Nice. So
for coordinates.
also using that trial and error, but calling some previous experience. Yes.
I got 400 and it worked,
Worth.
so I think it's.
Yeah, somewhere in that range. Time. And then you send your students on to the next step. It says how you can ball bounce up and then go back down. And so how do we bounce the ball down? I don't worry about that right now. Let's close this. Go here and try this one now. So coding back, I used to use quite a bit because it gives real short, challenging code for you to solve. So once they know just the basic structure, they can try to solve a very simple problem. So like this one says, given an array of integers, return true if the array is length 1 or more. The first element, the last element are equal.
Which group is that in? The one with the under array.
Under
Array one.
Ray 1. Everybody's first one under Ray 1.
I was kind of dead. It's kind of hoping to get a few bits of information from this and then we do take computer science. There's two things we were discussing about. Which sign is up for the break summer. I mean, and I could roll on the ball. Really, it takes this memory about it. I don't know how many else really are.
All right, so one of the reasons why I did two different versions is to highlight the difference in approaches. One of my early computer science classes, I had Barb Erickson from Georgia Tech come to the class and teach it with me. Her son happened to be in the class, so we kind of taught the class that year. And we used a lot of coding back. It wasn't called coding back, I forget what it was called. It's like a different name. We used a lot of this. Now I had a recent conversation with her, and she's of a slightly different opinion as regards to beginning programmers and how things like this, where you have to write code from nothing, can be very frustrating. And giving them something like the Khan thing, where they just have to add a piece of code to fix it, is easier for them to do. It helps them wrap their mind around the concepts they get used to seeing, the structure, and that kind of thing. So while this is great, I like coding back a lot still because it allows you to solve very simple problems. It might be more effective to give them something to work on where they just got to solve or fix the code beforehand. So just a philosophy back and forth between those two. Incidentally, one of the resources that is on there is a book that she and Mark Gooddown created. It's online. You have a student version and a teacher version, and it's free. And it does basically that. Like it gives the students problems where they just got to fix code and whatnot. It walks them through. It's designed to go along with CS principles. Just from what I've seen of it so far, it's pretty good. So just another resource. Also, for those who all don't know, yesterday we started a resource list. If you have any other resources that you find that are very helpful or useful for your colleagues, feel free to add it to the list and copy it down. I'm going to keep track of everything, and I'll eventually share this with everybody. Create an email list, or any new information that I get, I can send it to you all, and so on and so forth, and you all can interact with each other. More to talk about, well, I can go ahead and talk about it now. I created an EdWeb community. So you go to EdWeb, there's a professional learning community for Georgia computer science teachers. I have one for high school teachers, one for middle school teachers, one for elementary school teachers. Feel free to join any or all of them. I also have one for collective impact as well. That's one of the ways we're addressing the youth science education in the state through collective impact efforts. You can, and it's restricted, so when you join it, it'll send me a message and tell me whether or not I should accept you. Of course, I will. I do that so that I can avoid having so many vendors show up on there, start to petition to you all and that kind of stuff. It'll just be a community of teachers that are interacting with each other, helping each other out, you can see anything that's useful, you hear about some professional development that's available, shoot it there. There's a new program available out, Girls Who Code or something like that. You show it, put it on there so everybody can see it and be informed. Anything that I find out, I'll put on there as well.
Do we just search for your name?
Search for, well, she's on, she's on
Okay,
that.
'cause I'm already,
CS Georgia, computer science in Georgia, computer science high school in Georgia, something like that. What it's called. Oh, you didn't see. So I can use some teachers already that are part of it. Yeah, I got the Godot Computer Science High School, the Godot Computer Science Middle School, out of school, elementary school, and then the Computer Science Educator Faculties. So join me for all. It's interesting to you. In the high school. To build a membership. There's a discussion thing on certification. Probably do one for professional development at some point. I put links over here in the resource library. So I'll be putting, I'll add some more over there for websites and different things that are, I think, are important or valuable or useful. I'll put them on there as well. Yeah. Slow down a little bit. So, Alexander's showing up, great. She's out there. Oh, she probably sent that to me in emails. Looks like we're slowing down a bit.
You got that? California's coming online. California's coming online.
Oh, yeah, there it is. We've all looked at the, what's it called? Because all the cyber attacks. The Norse,
All right.
I think it's called Norse attacks. Put it in the website. People that are interested in doing cybersecurity. Norse attack.
Ryan, what do you search for to find your page?
Computer science, Georgia high school, maybe. Yeah. Okay. So for those of y'all interested in cybersecurity, this is real-time cyber attacks going on. You can tell where they're going and where they're coming from.
I never did.
That's- you got- you see
What's
that?
so special in Seattle up there?
Microsoft.
Okay, got it.
So we got Microsoft, we got Silicon Valley. I don't know what's going on here. There's lots of attacks that go here a lot. I have no idea what's going on.
Washington,
It's the,
DC.
It's not DC, it's Ireland. It's supposed to be Canadian born.
Oh, okay.
it's almost,
State of New York. There might be some secret military.
Seattle's also Amazon.
Well, it won't be secret much longer, they can get attacked like that.
And they can do it on a regular basis. Yeah, so that's like nice little cool graphics to show and see.
I'm gonna bring out for cyber patriot. Anybody has a first ROTC unit that has a thing called cyber patriot. Learning how to harden the Windows and Linux machine against cyber attack. Really cool.
Well, I've already signed up, it's just loading. Internet.
But did you?
Okay, because I had to join.
Okay, and I
And so-
joined also. So maybe I just need to log in before I can see it.
Well, I mean, it's the ones that are searching this, then the internet's taking a break now.
I'll go ahead and start the interview process. We got a couple minutes.
What did you search for?
So,
GA, DOE, computer science.
Is that it? High school?
one for high school, one for middle, and one for elementary. So we talked about the restructures. We said that there's sequential processing, which means it just goes in a straight line, one thing right after the other. Conditional, which means it's an if, then statement. And there's also iterative processing. So iterative is fun. It means something that's going to happen over and over and over again until some condition happens or is met. The first and most fundamental iterative process is a for loop. So a for loop has this as its basic structure. I have a Java background, so a lot of stuff that I write looks Java-ish.
It's my job.
I think he has a problem. If you ask him, he was having some complaints a little while ago.
He's got problems, all right. You might want to sit back and holler at me.
So the for loop, there's always an initialization process where you have to initialize a variable. So it might be int x equal to 0. So you start x somewhere, and you're going to go until x gets to a certain place. So you have to have a closing condition. While x is less than 365, you might say x plus plus. Now, this x plus plus, that's Java. It means this, x equals x plus 1. It means to add 1 to whatever x was, and store it back in the original x location. But they shortened it in Java to say x plus plus. They could even further shorter it. So what? I think JavaScript as well. Okay. So a for loop has an initial condition, a final condition, and then an iteration variable or iteration process. So something that's going to make the loop continue to grow. With a for loop, they do something called a pretest. So they test this condition first before you even get started. If you're already outside of this condition, then there's no reason to go through the loop. If x is already less than 365, there's no reason to go through the loop. And that can happen because we may have done x out here before we got to the for loop. We might have gotten x from somewhere else and said that x is equal to 307. So by the time we get into our for loop, it's already out of condition. All right, so there's a pretest for a for loop that determines whether or not you're going to go through the loop. So it starts off at 0, like I had the first time. It starts off at 0. Then it You open the loop, it does whatever it does. Then it gets to the bottom and it iterates. It goes up 1. So now X is 1. Then it checks the condition again. Is X still less than 365? Yes. And then it goes through whatever it's going through again, whatever the method says do. It gets to the bottom and increments again. It keeps going through the loop until X is 365. Right? So that's a for loop, the first of the iterative processes. Yes. The next one is a while loop. So while loop performs very similarly to a for loop, except for the fact that that initialization thing is definitely happening before the loop begins. So you say while X is less than 365, do this thing. And then at the end, iterate X. So a while loop also does a pretest. Checks to see first, is the condition still good? We're going to go through this loop. We are? Great. Let's go through it. Then we'll get to the bottom, we'll iterate it, and we'll go back and check it again afterwards. I say that because the next one, the do while, does not do a pretest. It does a post test. So a do while loop will always go through the loop at least once. Whereas the other ones, they may or may not, depending on the pretest. But the do while does a post test, you won't know until after you've done it. So it'll say do the thing, then if X is less than 365, X plus, go back up and start over again. So a do while loop will always operate or execute at least one time. Now this concept is a bit of a monster. Just because it's very challenging for students occasionally to wrap their heads around the idea of a recursive function. A recursive function, you say what?
Just laugh. There's professionals. Can't wrap their head. There's an adult that can't wrap their head.
It's true. Now, let's say it is a bit of a monster. So a recursive function, to put it simply, is a method or a function that calls itself. So at some point during that function, it's going to call that function. If the function is named 1, 2, 3, which I don't think the name of function 1, 2, 3, then at some point in the function, it's going to say x dot 1, 2, 3. Call 1, 2, 3. What it does is what it creates is a stack. So you have the first function that you called initially on your own. Then that function called itself. Then that function called itself again. Then that function called itself again and again until whatever the condition that it's looking for is met. So think about like the example I gave yesterday was terrible. Let me see if I can find it. And the thing is that you can do loops. You can do a for loop. The same thing you do a for loop, you can do it with a recursive function. Same you can do it in do while or a while loop, you can do it with a recursive function. Not necessarily vice versa, but you can use recursive functions in the face of loops many times. So the example I gave yesterday could have easily been solved with a loop, but I made it a recursive function. I looked at it like a picture that you're going to take the red eye out, and you look at the whole picture. So you're saying, okay, is there a concentration of red pixels in this picture? No. Well, let's make it smaller. You call that function again. Is there a concentration of red pixels in this picture? No. So you call that function again, make it smaller. Is there a concentration of red pixels in this picture? No. You get down to the eye, it says, is there a concentration of red pixels in this picture? You say yes. Great. Then do the thing that makes those red pixels not red. And then it goes back up the stack and it pops off. You file out the function. But it'll continue to call itself until it solves whatever the problem is. That's recursion. That's recursion. Right? Anything you can do with a loop, you can also do with recursion. I had a student that's very precocious. I would tell him to do the program this way, and he would do the program the way he wanted to do it. It would work. Beautiful functions, beautiful programs. Often longer and taking more data and more space than they needed to, not very efficient, but they were very elegant. He was very good at what he did. He refused to do things. He loved recursive functions. He would always do them for loops, even if it was a very simple loop. He said, look, go through this array and find this number. He would create a recursive function to go through the array and find the number. He goes to Georgia Tech now. I think he's in his 3rd year at Tech.
Don't beat it.
Yeah, they'll give him this. I let him go. I was like, look, as long as you get it in on time, as long as you get it in before the last deadline, look, just finish it before the semester. All right, so we'll do this one and then we'll break for lunch. Move a little bit faster today. Might be done before the required time frame. I know you all will be upset if you want to stay the whole time. Feel free.
It's a nice breathing.
Back here, we're freezing.
Apparently you have ice cubes in your life.
Look, when I came in here yesterday,
That's
I'm not gonna touch it. I came in yesterday and I turned it on warmer. And
no, it's not, because you know what? Germs don't fly, breaks the air. Well, the keyboard had more germs in public policy, you were picking out first.
okay.
I did my class right here. I don't know these problems. I will up with a lot. Yeah. But yeah, I bet you recorded them doing it before instant administrators. This is not fine. I know it's and I'll definitely let either paddle. They'll run around the street. Best course I've ever had on top of Thank you. Mine's actually.
Oh, somebody dropped out.
Yeah, mine was actually. No, we tried.
Are you coming back?
For whatever reason, they would change the game. You get a second. But it's on, oh my goodness, okay, here. But I use it.
All right, 24. Anybody else?
Yeah.
No, one more? 25, all right. A method or function that calls itself is called something. Oh, wow. Ooh, ooh. Somebody's paying attention. I like it. Good job. Bravo, class. We'll see when the answers come up. Put your answer quickly. This will be your answer correct. 24, one more. Method or function that calls itself. Recursive. Nice. Nice. All right. Now, I'm just mention this real quick. So methods and functions are pretty similar, pretty much the same. In some programming environments, they're called methods, and some they're called functions. And some, they have both. And what they'll do is they'll have methods are written inside a class, and functions are written outside. So in the main, if it's written as something to do, they'll call it a function. So, but they pretty much serve the same purpose. They can often be used interchangeably as terms. It's what the class or the object can do. All right. Yes. Which iterative structure will always run at least once, which means it does not do a pretext. Do while is the correct answer, and we had lots of those. Nice. All right. Do while will always run at least once, doesn't do a pretest. For loops and while loops do pretests. Conditionals are not iterative processes. If then statements are examples of what types of statements? Oh, wait, whoa, wait, whoa. Y'all have seen those before, I think. Huh?
It's all the basic.
On the basic. This is basic. I tell people that I know COBOL, like, ooh, COBOL? Nope, I don't know any COBOL. Nice, conditional, yes. Everything is conditional. Loops, for loops, while loops. JB is leading the pack, which is not an example of an iterative process. So all of these are iterative except for that right there. I'm looking right at it. Conditional, yes. Nice, nice work, yep. For loops, while loops, and recursive methods are all iterative. They're all going to go through a number of times until some condition tells them to stop. Which data type is either true or false? Boolean. Boolean. Nice word. Boolean, 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 Boolean. Boolean values are either true or false. True or false. JB. You had to lead the whole time. JB, 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 right there. BS, right here, and Beth H, right there. Get the switch, you guys. Don't let them talk over you. If they say anything, let me know. Yeah. All right. This coding back is for loops. So create a loop that will, recursion, without loops, so using recursion. Create something that will have the bunny, that will compute the total number of years across all the bunnies recursively. So you're going to get a number of bunnies, and you add all the bunny years. So spend about 10 minutes on that and then go and get something to eat. For those of you all who haven't gotten one of these, this list up here tells you all the food places are close by. Something for everybody.
You should email the staff.
Well, they have these over there at the front. There's a Sonic. You still in the mood for slushy and some breakfast? It's cold outside. It's cold in here. We got Marco's Pizza. There's Japanese Steakhouse. You all go to Japanese Steakhouse. I like the salmon rolls with the cream cheese on them. Little sushi joints. Step by. Fazoli's. Crystal. My sister's name is Crystal. A number of bunnies. Each bunny has 2 big floppy ears. Every bunny has 2 ears. The total number of ears across all the bunnies were recursively between at some point in this program,
Yeah,
which is called bunny ears again.
0.
Brian,
Yes.
did you say that Barbara Erickson wrote a book? Or
Yes.
what was it?
Very useful. It's called CS Principles, Big Ideas in Programming.
Big Ideas Program?
Yep, right here. Interactive ebook.
I was teaching some great, you know, it's on the yard.
So we have return values about 20 years.
That was that book that we talked about earlier, no, so.
Each time through how many years you have. Sorry. Go through each one is every year. So, 4 Is that quite, first time through, buddies is 4. And 2 years. Sorry. 2. Buddies is 4 years. So you have 32, so you have buddies. So you always have 2 years, so one buddy is 2 years. So you return 2, buddies is 2.
And that's what I'm saying.
And that person you call next.
Yeah, this is like,
Is next stuff.
this is. We talk so the basic structure. Plus.
Next year.
So we're areas. So like, before you can actually really see, one understand like more the structure of what we're doing. Could be one, like, great way to get that. And we'll talk about some of these resources. I'm sorry. Misery loves self. Yeah, it's on our minds. So this book is free. Like, so this is just it's free. Let's start.
That's the answer they expect.
There's a whole. I think it's John. Start trading, so that. Yeah, it's more. Yeah, I would think just
right now, you're zero.
Your schedule's true.
Yeah, Mr. Tracer, what, if they want to, what is it, and I was like, I can do it, but it's like, I'm not gonna get done. That was amazing.
Well, I make them all with your
Does anyone out here teach the programming maybe at society class? They have 2 kids.
I'm emailing you if you want to.
How long have you taught it? How long have you taught that class?
And I will, I'll share out. I read part of it today.
I kind of
Put it on the web.
right? Yeah.
I said 420.
So I did it, I started off with Java, which was.
It just gets overwhelming.
Yeah, it gets to be a lot after a while.
I have resources and then it's like, where you say, Library of Congress, they're like, okay, what are they like?
Exactly.
I think that's that.
I don't have the necessary time to go through and then. So
He did.
the ones that I do know, I'm like, oh, okay, I like this. I like all that other stuff.
Yeah.
Mobile app.
Okay.
And then we just had y'all working people, right? He did Unity, he did Audacity,
We did a
he
whole
did, some of it. So what I did, because Java kids, like, remember how you say, they use Java. So another one, coding that, and said it was easier for kids to have something to solve.
So that's,
Was without.
So it's just-
You do it
So
again.
they had some language experience with
Then you don't
Java.
allow kids.
It's still
That's crazy. I'm great. And then
we just went straight.
Yes.
Yes.
Got a couple of just AP level, APCS. Practice it. Practice it.
But I'm planning on doing everything.
And then,
As far as.
Georgia, Harvard, Harrison have a lot of courses. ICE, AP exam. So the kids can build their own set of questions. I'll email you the link.
Okay. I'm actually on that link, like I said, she talked last week.
So you're on her distribution list?
Yes, so she talked last week and all our materials that she put on there, like.
Most people are doing it.
You do the.
They gave us the.
No, it's,
We need to be all.
New book, you book. Yeah, you book.
I got a job where you book, but I got the.
We don't have
We got
This one, she said, they're great, I just kind of have ignored it.
What I did is I chose what I
And I
felt
put it together, and my kids.
and I just looked at the blueprint and then I thought the stuff that I covered, that was the test I chose, which was, the Microsoft TA Software Development Fundamentals. And I only had 2 people in this. And those were the students who, you know, just their whole life is
Job.
I'm at Shiloh. But Mike actually was here, he used the same test and he had a 50% match.
Are you with Michelle? I think that is, I think
She didn't know. She taught
I just sent her an email and said, hey,
But you know, she does it online.
All right, did anybody get the bunny ears counted?
Doing it online.
You wanna share with us how to count bunny ears?
Yeah.
Of course. But
You got it, you got it, here we go.
Did you do end of pathway for the program?
Has she told you, Sharon?
It's the HTML5.
She decided on that already?
It's HTML5 because at the academy, they had that, in December. They used HTML5.
Who did?
So,
Or,
Y'all school?
or,
so I
let me
need
see,
to,
what does she
it's gonna
teach?
be,
You talking about?
Drafting teacher? No, it's just read the name.
Are you serious?
Yeah.
Which HTML? Or
that's where I got my.
So it's again? Yeah, we did that HTML5.
So when she replies, see, I don't know.
It's one of those, set of.
And they actually gave
The single middle sign is an assignment. And I'm gonna take what's over
For
here.
the programming games. For the programming question.
We ever see a single.
That's what they did. And,
Yes.
I think you have 3 to choose from, but I think we
We'll
chose
talk about that.
HTML5.
So you.
When I first heard that, I'm like, that sounds like we're designed to this game. I thought it was a mistake.
The kids that are in the PS files.
So we did that. That's what she has set up.
No, the only thing you can do similar is the mobile part where they're creating apps. Right. However, that knowledge that they gain from that class, it can still help them because Java, and Java language is similar. It's just that the JavaScript needs the browser to run and the Java can stand alone. So
So I
You
didn't
still have your
understand my
e-statement.
text. Okay.
Richard,
They did in the job.
Richard.
You still have your function,
I'm with you.
so that's the job.
Richard,
Function that is-
did you do in the factory? What did you do?
I really.
All right, looks good.
Oh, you didn't do it.
Just the way.
All right, so we have a solution to our money problem.
HTML prior.
You notice that here, she calls bunny ears again. So
I'm
this
not
is
sure what you said there.
a function that calls itself later on down the function. You know, do that until it gets all the bunny ears. So, encourage you. Although, as we just for all the right French answers. Go forth, eat well, come back here in about an hour. See what we can read 12. 12, sharp. Sharp.
Can we say log on? Can we say log on?
That's fine.
Well, Renee.
Started in 93.
Sonia, you're leaving this thing in your bag?
I was gonna leave my bag, you think it's safe? Maybe I'll just.
Richard's leaving his too.
Does he have his laptop?
I'm interested to know myself.
Okay, then they give you permission to come.
Well, I'm excited to, I could vote for Wednesday.
Okay.
And I'll get something.
So in this was my staff on
Yeah, well, I don't let them, you know, you can go vote again, it's like I already got, they're saying we weren't there before.
This was developed.
But I emailed him, he asked Joe, if he's ready to come, he'll just,
Once we
talk
got
about
it
what we learned.
somewhere in here,
Something at one of the rounds, just talk about what we learned, and that's that. So we can both go to him tomorrow, say, we both were there, and this and that, and that's all they need, they don't really need to.
development.
You can,
Yes,
how are you? How did the course, the
Yes.
year in?
Yes.
Okay, how far did you get on code.org?
Okay, I had to skip 4.
Different development.
5, and I got 3.
Two.
Yeah, I didn't do that.
And this was the same QA.
Yeah.
So what happened was,
And
development
you
staff
just did the first
stayed
chapter, about like the first half, me
development
too.
and release. Testing.
I was
And then
thinking
this
you were
staff
third
stayed.
one.
Yeah.
Well,
I was
they
thinking
came
back
back
up
up here.
because they're gonna need that.
Yes, I was like.
And then development staff go back down here. So that's city analysis.
Gotcha.
Yeah.
You'll just have to switch, you know, you may have not have it in the same class, so you'll try.
If you were doing
Right.
this, if you were releasing
Yeah.
Where is it going to lunch?
complicated
We're
product. Actually, everyone.
Leela's
Shut it down on Friday. And work on the big Saturday. Sunday. One are using is all web days.
And so how did you end up?
Yeah.
Sorry.
We ran that model
Your friend just said.
until 2007. That's when so
Yeah, we used to work together.
we slowed down to 3 releases a year by that point. But what I had to do was these types of analysis. I would have to determine what was critical. We want to do all these things, but what did we do now versus what did we do in 4 months? So it was an amazing process. A kid that thought of it. I was in my 40s when I joined the company. The kid thought it was 29. Or implementing it, it was brilliant.
All ages. All ages. Thank you. Hello.
It was ad that I was trying to. But, I heard it sound. Teaching some. So I tried to. Change. So what is it? Is this what's on the? So. We just initially said that this is like a freshman. The basic. So we didn't get our teaching assignments until like literally her. So we couldn't
I don't take it as like, I don't have any issue.
Yeah.
I don't know if there's a
Okay.
type of thing to do. I don't know. That's the other, I assume it's fine.
Okay. Thank you.
Enjoy time, enjoy your life. So I'm always about enjoying it. All right. The rest of me, all right.
All right. Yeah.
No
I
problem.
want to hold you up.
Oh, I'm ready. When I'm good,
I'm just going to chill. I want my little snacks.
I'm saying, I guess when I came in, but I had told them I couldn't see. Not me with the whole time. Okay, so now. Yeah, the sign in there.
Oh, yeah. Don't forget to sign in.
So people pouring down.
Is it raining now?
I don't know about now, but when I'm coming up.
Okay. Anyway, all I know to say is it's worth a try, right?
Yeah, I'm gonna drive. Yeah, I talked to her about that. He was saying, who've been teaching.
Yeah, those are the people you want to talk to.
Yeah.
And you know what? I got something I might be able to share with you. Are you going to do IDT?
Yeah, I do that
I
now.
have the whole curriculum.
Oh, you do?
Yeah. If you want it, I can give it to you.
Oh, yeah. Email that to me.
Because,
Yeah, I do that now.
this is so great. First, I'm with Boca County, and I went to the orientation program. And the link that I sat down, we have like 500 people in this room. I just so happened to sit down next to this lady that used to teach IDT. And I was like, I don't have any curriculum. She goes, here, I got it on the jump drive for you. She just gave it to me that day.
You never know.
So that was like my first sign that everything's gonna be all right. Please. Right, that's a little warmer. It is.
On the way back, I'm gonna go into my car, get my blanket.
Do you want to say this on your OneDrive?
I got it first drive.
Oh,
I got OneDrive and, get that all the stuff, you know, change it.
Oh,
I don't want to, you know,
I got you.
yeah, they, right, they told me I would.
I know this feeling.
Okay.
Let me use this up. Make sure it's It's a whole nother world. I know, right?
Flash drive in already.
Yeah, mine in the back. Let me see where I stay. Oh, I'm gonna put it on mine. Here, you can put yours right here.
So you got one.
Yeah, I think. All right, I'm having an email problem. Let me get to this thing, and then we gotta go back to the coding backup. He gave us a button. Okay, cool, I got it right here. So. I'm just showing what it looks like. So it's got, this was 2014, 15. Maybe this is for, I don't know how she's dividing it up. Maybe it's by standard.
Yeah, look like she did about that.
So it's pretty cool.
You can go down and she was there, the basic guys. She take it.
Okay, so down here. Ooh, okay, this is. Let me see if I can.
I shall return.
All right.
Found.
I'm gonna have to do something, I'm just gonna have to share a link with you.
Okay, that'll work.
I don't know what the heck.
That'll work. Oh, wow.
All right, I think I'm gonna need you to tell me your email address.
Oh,
Hang on one second, let me get over to that spot. All right, Erica, share. So, no,
it's DLCSchool.org.
all right, let's see. I needed to use this, let's see if we can transfer from your OneDrive over to here. That's what you want to do.
Oh, yeah, long as it-
Because I don't want to accidentally delete it. You know what I'm saying? If something changes with my account, then you're moved up to it. So this way you can be independent. Oh, yeah, there you are. So over here. Oh, here it is, right there. Okay.
Yeah, that's it.
Oh, wait, click on this. And then, open. I should have named it. All right, so, yeah. You already opened it, though.
Yes.
Well, just
Let me
click.
see.
What?
Let me get it. Send to that email. You got that email?
Well, I'm gonna send myself a message, and then when I get home,
Yeah, that's what I'm saying.
I can.
Yes, send it to me. Check. That's what's her- all right. Okay. That's it.
Oh, yeah, okay. But, we need to figure out
That's it.
how to save it to your computer. Okay, let's do it. All right, much slower. Why doesn't it let us download it? Why can't we copy and paste it? Yeah, but I think it's attached to me, so if something happens to my account. You can go into each one and see it.
That's a long, that's, it's got to be a short wish.
I know, we're gonna,
Oh, I see. If I put all of that. So,
oh, good idea, okay. Yeah. Okay, we'll try that. Okay, yeah, it'll be easier that way.
it would be options.
It's not, jump drive, not coming up, right? It's in there, see?
Yeah, I see it.
Oh, okay, I know what you do. Okay, good. Let me see what I can do that. That's on my computer. I know, I got it. Hang on. I think it. Because my computer is,
You want to have one else?
yeah, I got it synced up like that. So maybe I can fix it out. Okay, it's not so bad. You know, mileage is being reimbursed for this. You filed that report? Okay, but not a hotel, but the mileage, yes. Okay, good.
That's it, man. You know, we did that. We got that. We got our first.
Oh, really? Okay, we got out of the trouble.
See, they had two storms. First time.
I looked at Tennessee before I moved here. I remember last year we had about 10 students. We had 5 in one quarter and 1 3 next week. 3 in person. It's crazy. Cool, maybe that's good. That should be everything.
There's,
right, I got it. It's fine.
Yeah.
See, you know how you're gonna get yours to look like this. So I got it. It's, it's loaded up on here, but not on the other. It's Control C. Copy that to here. Did you already fix it in? You just put anything in there. Here you go, I need to last.
See, it works. That's all I need. See, they might have what I got mine. So, the kid, 9 years old.
What's that?
The way they play it, you see, keep it from down.
Oh, okay.
But I got it like that. They got it over here. They don't ask. We might walk around. This house. I had big.
Their thing is all about games. They're always trying to play that basketball game and the NFL game.
Oh, okay, that, yeah. It's like the main way that they came. So, you know, not in the 8th grade. So,
What made you decide to leave?
well, I had gone in from mom, that's still bad now, so now. Now.
So you just had to take the gates?
On that one, I'm already certified. Business. Political science. It's cool. So,
I think I need to take the business and computer science case, because I took the practice exam the other, in Tennessee. But I think I have to take gates over here.
It's a shame that we teach them, it's going to be a way to, get credit for it. How long have you been doing it?
3 years.
That's awesome. Let's see how long.
Yeah, I'm not sure. It's gonna be-
But they invest the money.
I know, but there's something about my license,
I state,
because I just did the ethics exit,
oh, Ace,
because that's, I went to teacher school, So,
that's what they're doing, they're sending you carry to a new state.
yeah, okay, so I did that, so maybe that's gonna update my, maybe that's all that I need to do.
Yeah, I'm saying, you probably told somebody that can chase it. And he said, it's not anything, but you do it. So I took a little bit of science, but some of the computer science. So I'm going to take a test for all of these. I took the mission system, so when I was looking at some of the stuff, I came to, sit down.
Get some big.
I'm trying to take it, but that's why I can't look at it.
Oh,
Yeah, yeah.
that's right.
I took the class. So when I was doing, I took classes that presentation. Text.
Texas.
Yeah.
Did you hear what he said? He said that they use the Texas praxis to make this case.
Again, I said that to my parents.
Yeah, the Texas one?
Mhm.
Yes, but he said that they use the Texas one to create this one. And then, he said they're gonna change it, but they haven't changed it yet.
Yeah, they might be. My son, that's the guy he was teaching the care of him. He sent an email and told us to take his class, which we played about in Texas, repeat assignment. So I took
Oh, okay. Let me get, I think I got it on
the life. I'm gonna tell you this. That's the same thing. Do that stuff. So
I'm gonna do that now on my judgment.
that way, anything happening in one class, I know that I have mine, I got tuned out.
I want to transfer it over to my personal. I was in States.
Yeah, because I had one that got messed up by then. I learned not ready for school.
Oh, I ordered that with my state money. So sometimes I just keep them in the pocket. Little girl.
I got
one.
four. Yeah, I did four. I got 32 but I put mine every senior. It's very, because they got a virus. So I had to hurry up and do this and take it off when I use it.
Work out.
Mhm. Sure did. By the time I got everything on and put on there, I knew it was coming because it was like a teeth thing. So we got to move fast.
At a time, right?
So we put one of the tests.
It's so crazy they see their bells.
Yeah, the students end up playing the game. Europe, New Zealand, yeah, they end up doing it. So, we get somebody. Get credit, you know, how they had some leagues and stuff. Yeah. Cuban, so we not great. You teach in Northwest.
Yeah, Northwestern.
What's that called?
Is it like Alpharetta?
Oh, we're out straight down. Yeah, okay.
It's a whole other world, my friend. When I first got there, I used to teach in a Title I school.
It's a huge difference.
And it was so funny because my first week I was talking to one of my teen teachers. She teaches family consumer science. And he said, okay, what's the name of the backup printer in case mine goes out? She's like, it's going to be fine. I go, I know, but just in case. She goes, it'll be fine. I go, I mean, my printer might go out. And I might need a backup printer. She's like, did you used to teach at a Title I school?
So
She's like, seriously, don't worry about it. You will be okay. I am just blown away.
Yeah, great. You know, that's one thing. Yeah, that is, you know what kind of type of stuff.
Oh, yeah. Now, it's so funny because my son goes to the elementary school. Oh, guess what we had for lunch on Fridays? Fried shrimp. Not every Friday. Not every Friday.
You know what? Yeah. Wow.
I know.
That's not a title one.
I went to the elementary school, like I was just saying hi to my son at recess, and I was talking to one of the other teachers, and he was joking around, he was like, yeah, well, I knew something was special about this school when I saw the cocktail sauce in the packets next to the ketchup. Ah! Oh man, I'm not gonna mess up this opportunity. I'm gonna try to keep this going as long as I can.
Yeah, I learned a lot, so my participants are doing that.
I mean, middle school, wow. Well, oh, I used to do a club, I didn't get paid extra for it.
See, that's what I don't
Did
know
you?
about the time. No, they don't.
Like,
See,
My
that's
teacher,
wrong.
she teaches robotics, she comes in like an hour before school, a couple of days a week, she gets paid a stipend.
You see, that's what they both do. My customer said, no, she can't come in. I gave them last night, she was telling me how. He said, what is it?
I never got paid on one sleepover that I went on in September. I never got paid for picking up donuts on my way into work.
I see that. That's, I think, the type of money. Not me, no more. That's that money.
Do they? Go to the lunchroom, stretch my legs, eat my yogurt.
I had to pay us. Yeah, they doing the, some of them, they not watching. The crack.
Oh, that's, okay.
Yeah, once I get out, get tired of one. That's it.
Right.
They train me well.
Exactly. Exactly.
Said nobody coming.
Erase the passwords. Oh, you're good.
Person on the other side.
Remember the password for the race users?
Yes, 2017.
Summer 2020. And it's back to us. Thank you. Well, I don't know, but I might have just marked it.
That's for
What was the last name? Next. And then they have programs all the time, so I can get that. Her introduction to Python. Make sure I got my kids, so that we can financial aid and their financial robotics. What you do, like a job program. One where you don't really get an active participant that you can just watch. It's terrible. I have been working on for really years. I'll just look at teacher program. I'm an online student.
The one. I was seeing how long it is.
You see it's in election, like the, break hot sauce, you get to do that. And they say it on their phones and what it is that if they can get away with stuff, a lot of that just walk them to do the work. But it's the bothering. And somebody told me that there's a, if you
Okay. I got that.
Yeah, it's fine. Here's one for just a lady right now, but it's just her syllabus. It uses Edmodo.
Sarah, did you take a picture of that password?
It's up there.
Some.
It's first semester's hardware and software components.
First one.
Mhm.
How long does it take to do that? I'll send you an email.
Ask her what she uses. Plethora. That's 2014, 2015. Oh, here, did I take a picture? Carol Myers, just looking at the rating on this. I bet you go to Howard High School's website. See, this is Dr. Java going to Visual Basic 8, it's first edition. That's Calhoun. And they use 2 books. Takes your apps and games and dates techniques. Started yesterday. I don't know what. Okay, certified coding essentials. For APIs, game techniques. I don't understand. Just put the other by the 13. I like this.
Me too.
It's all
Well,
right.
Yeah.
I thought it was very
I'm working, so.
It was pretty good.
I just think since I went to the doctor and
So that was kind of clean.
but they have a prayer at PhD, the 01 leadership certificate.
Yeah.
And I'm like, it's the same amount of time, one, it's pay raise, one, keeping the options.
Okay, gotcha.
So kind of like,
That's your question.
Yeah, I didn't have your keyboard, my software was over there.
right here.
Yes.
Okay, for programming games, Action Society. Do you have any kind of materials or resources that would be available on what we should do to get started in that course?
Not yet.
Let the course will start.
Brian, what is your response to that question?
Not yet, no. If you want to poke your head in that session down there, you can, there's a programs application society, session going on down there.
Oh, there is?
About 2
Yeah,
or
but I
3.
needed this thing first.
What are they?
I think it'd be last stream to do the programming out the end.
Are they gonna live stream that one?
No, I don't think anybody else is doing it because
We need to find out who's teacher.
Okay, is it on your channel? Do you have a YouTube channel? Is that what we need to, for yours?
yes, yes.
Just be under your name.
Brian Cox, Brian C.K. Cox. Right. New initials.
It's the code tracing, whatever you say is about the test. Is that?
No, I don't know, maybe 40%,
That's a high number.
Yeah, it is.
That's a high number, 40%.
But then, you know, it might not be the same. They had a couple of questions on there that were just test questions that they threw out eventually. They will tell you which ones they are, they're not. Everybody sign in? It's the same sheet. Yeah, 1, 2, 3, 4, 5. Let it make it.
Locked up.
Make sure it's going down to that thing right now. He's going down there to see if there's Google Docs and everything like that. This is that headaches. Well, this is, they have all kinds of free things, so they have a coding one for free. You can take any of them. The one I have, I don't even know what it's called. Yeah, if you go to edX.org, you can go to computer science and see.
I sure wanted my summer.
I ain't on the summer. What's the summer? I'll have to teach myself.
College visiting,
I need to make sure that I'm passing my class. Pass that test, but if the test is not open. It's the last one that's open is for the June one.
June,
That
and then what is the next?
The 2017, 2018 listings of when that programming. Gates is available, it's not open yet. But if it falls like last year, it'll be October.
And that would be the only time before it's 2018.
It looked like it was October and then February and then April, something like that. Or that, that's
So,
a lot.
I need to jump in and out.
Yeah, let's see if I can pull that open again.
All right. Let's get back to it and push through. How's the bell?
October, February, April.
The next section is class creation. We said in object-oriented programming, the central piece of the programming is the object. That's the part that makes everything go around. Everything is an object, everything is viewed or abstractly created as an object. A class is a definition of an object. All right, so this is a general definition of a student object. Now, I can create a specific student, give that student the name, the age, the grade, and that will become a specific object. So object is an instance of a class is a definition of an object. Objects have attributes. Objects have attributes, things that we know about that particular object, grade, age, hair color, different things that you can know about, or adjectives for that object. An object has methods, things that that object can do. So verbs. Variables. A variable is a placeholder. It identifies and points to a place in memory that can hold some type of data. Right? So when you create a variable, you might say int x. So you just created a space in memory and have this x that points to that space in memory. Now this space, because it knows that it's an integer, it knows to allocate a certain amount of space in memory. How many? 32 bits. All right. After it creates that space and allocates that space available, then you can fill it with stuff. So you say x is equal to 5. It takes 5 and it puts it in that space in memory. Right? It may not fill up all the space, but now there's a 5 there. You can rewrite it, put something else in there, and so on and so forth. You can do both of these things in the same line, like this. This is pseudocode. I don't know what the actual language uses an arrow. In this one line, it says create a variable named x and put 5 inside of that variable. It's all in the same step. But you have to declare a variable before you can actually use it.
Java is bar. Java is bar.
Java does not use bar. I don't know. Yeah.
It gets big, so I get mixed up sometimes.
Now, variables can either be local or they can be global. Right? A variable is local. For instance, if I write this method here, inside this method, I create a variable and say int x, and I do stuff with that x, and it happens inside this method. This x only exists inside of this method. It doesn't exist out here. Anything else outside of that method can't use that x. It doesn't. There's no relevance to it. It doesn't even play into the role. Right? However, this variable int age is global. Anybody inside of this student class can use age. I can have student. I can have another method over here called can graduate. They can have stuff. They can use age. I can have another method over here. Can says got suspended. They can use age. Age can be used in all of these methods because age is global. It was defined out here in the general place. It wasn't defined inside one of these methods, inside a box. Each one of these methods kind of has a box like that. Anything inside that box that's defined inside that box is only used for that box. It's local. Anything that's defined outside of the box, but inside the class, is global. So variables can be local variables or global variables. Operators. A lot of the operators that we have in programming behave similar to the operators in math. Many do not. So for instance, in math, this statement says that x, whatever's on the left side of the equal sign, is equal to whatever's on the right side of the equal sign. That's not how this works in programming. Programming says, take what's over here and put it over here. So now this x, whatever it was before, is now equal to 5. So in math, you couldn't have this statement and then behind it have this statement. There's no way that x can equal 5 and 6. But in this one, it says x equals 5. Oh, now make x equal to 6. So when I ask what x is later, we'll know that it's 6. If you want to balance equality in programming, you use a double operator like that. This is a statement of equality. These are statements of assignment. This is a statement of equality. You also have, what else you have? You have modulo, which is not something that's often used in math class. Modulo is like division, except that instead of giving you the dividend,
It gives you the remainder.
it gives you the remainder instead. Right? So it throws away that other part, that main part that you used to focus on in math class, and just gives you the remainder. It's an interesting operator. What else? Operators don't only work on numbers. They work on characters. They work on strings. You can use this with a string. You can use this with a string of letters. Find out whether something is equivalent to something else, whether it's true or false. Like, so there are operators that do different things in programming than they're allowed to do in math class. You also have operators that represent the logic gates that we'll talk about later on, like ampersand. This says and. So that means that if, in order for, you might have a conditional or a for loop that says that this loop is done when x is greater than 365 and
One greater than 2.
so y is greater than 2. You have, I was trying to use a different thing like
And can graduate.
and can graduate. Thank you. And graduate. All right. So this is taking a comparison of a value to another value, but it also has to have this truth statement on the side over here. So both of these conditions have to be true statements in order for you to perform whatever action is underneath there. Right. So lots of different operators and things you can do with without operators. Methods and parameters. All right, so we said a method is something like this. Something you can tell that so you can know what the object can do. So it's a definition of action. You'll notice that these methods are the same name. Earlier I called them constructors. The constructor method is responsible for creating or instantiating an object of this class. So if I wanted to call out a student, or to make a student object, I would use one of these constructors. They're different constructors because they have different information that they take, different parameters. A parameter is information that's given to a method. Given or passed. Or passed. Passed to a method. So this method is not passed anything. It's the student constructor, but it's not giving any information. This one is passed the age of the student. So even when I create the student, it'll automatically be created with an age already that we told it. This one is passed with a grade. So when I create the student, I already know that I'm going to create a ninth grader or a 10th grader or whatever. Right? So these are different constructor methods. And each one has a different parameter set that is given. Anything else here? I mentioned functions and methods are often treated the same depending on what language you're working with. Some use functions, some use methods. Some can use both and call anything inside your class a method, but anything in your main, which is where your program actually runs, they'll call that a function. So it depends on which language you're playing with or operating with, but they essentially serve the same purpose, and for the most part, it's the same thing. Now, this pass, this parameter pass, when you give this information to a method, it can either pass by reference or pass by value. If it's passed by value, so for instance, in this one right here, I pass grade to student by value. That means all I'm doing is giving this particular method the grade. I can do stuff in here with the grade, I can even change it, but it doesn't change grade out here. Because I only pass it to value, I only pass it whatever ninth grade. So in here, even if I say, if I promote them inside this student, if I say over here, if I give can graduate a grade, and here I say, well, take that grade and make it equal to 10th grade, so I can do some work on it. That's fine, I can do that inside there. But if I pass it by value, it doesn't change this grade here. This grade stays the same. If I pass it by reference, that means I'm still referencing this original grade, which means if I change it here, I change it out here. So if you pass by value, it doesn't change the original. If you pass it by reference, it changes it outside of that number.
Java doesn't really do that. I mean, like C or C++, you can specifically say it's passed by reference.
Yes.
But Java doesn't have a clear way of differentiating that, does it?
Let's go back. If I'm not mistaken, you have to change global variables, basically.
Yeah, to make it.
You have to go back and change the global.
But this is like there's a distinction in Java, other than you're not, it's not an instant variable. Concept. Like
It's a new word concept to me.
All right.
By the way, as you start looking at the Gates test, I don't think Python doesn't have a distinct point of view. It doesn't have reference passed by value.
Look at it and see if they.
As I'm saying, as you look at the Gates test, those are the kind of questions that, although have value, may not exist in today's language.
There's probably quite a bit of that.
Pseudo move to Java or JavaScript, Python, sure, when you're used to. Because Python does a whole lot different than Java without a core. Not true.
And that's one of the reasons why they advise us to teach general programming concepts as opposed to a particular language, because things are different from language to language, and if you understand the general concepts, then you can modify it slightly when you learn a new language.
What is the Gates test? What is the Gates test?
Most of the pseudocode. Most of it is not language specific. It's kind of the you'll see the word is generic. You'll see the word in else, but you won't see the curly brace structure necessarily. Right. But most of it's pseudocode. That's correct. It's true. All right. Anybody else? Good to go? Yes. type of variable is available outside of method. Global variables. Nicely done. Inside of method, they're called local. Universal logic. Values passed to a method are called nice. Constructor is a type of method that creates a piece of a class. Function is another word or method in the language you're speaking. The definition of what an object can do is called done. The definition of what we can do is called a method. Parameter is a value passed to a method.
Look at number 3.
This is too high. A parameter pass that does not change the value of the original variable is a pass by Nice. So reference means you're still referencing the original. You can change the original. A method that creates an instance of a class. What is that called? Done. Structure creates a class. JB, Linda, and West H. This exercise is an exercise which click. It's nice when you start talking about variables with your students. And to start getting them to think about tracing code. You know, probably the most fundamental way of tracing code is just to identify what this is saying. Value of x. X is y. I got something right at that. That's, they see that it's still glowing. Not even off, just.
Ready to go.
Really hot. That's good. Yeah, bottom there. Step-by-step solution. Shape should be as tall as their height markings. To the lips, go up each of the height. What I have passed each of the communities, each variables, the height of each of them, whatever. Continue, but you got some arguments that you had, the shapes will be fixed in picture. What issues are they taking on? Issues. Yay. Alright, so
He's anonymous.
alright. Data structures. So we talked about data types. We talked about some programming and control structures that move the data around. But we can combine data types into more complex structures as well. Structures include things like arrays, queues, linked lists, binary trees, graphs, things like that.
It's supposed to be arrangements. It's supposed to be arrangements. Where you said arrangements.
On the top, title.
Oh, it's about should be arrangements. Instead of,
Proceedings.
see what?
Got a combination of court proceedings there, kind of have some arraignment and some arrangements.
Arrangements, yeah. Oh, obvious. Next iteration. I say that.
There seems to be a recurrence of I'll fix that.
This is the second time.
He's a programmer. That's what they're saying.
What?
It's just documentation.
We talk about documentation, it's important about documentation. Depending on the situation, some structures are more advantageous than others. Look at the first one. One of the more basic ones is an array. An array is a contiguous space in storage for like data. Contiguous means it's right next to each other. all has to be the same data type. So if it's strings, then it'll be an array of strings. If it's integers, it'll be an array of integers. The use, one of the utilities of an array is that it's easy to identify and address a particular element, called element within an array because it's indexed. So the first element in the array is at position 0. The second one is at position 1, 2, 3, and so forth. All right, so if I know I want to find out what is at position 3, I can address that array by this index at position 3. So say, for instance, this array was named num, right? I want to know what's here. I want to put it in this variable. Int x is equal to num3. That's going to take whatever's in position 3 for this array, which happens to be 8, and it's going to plug it into x. So now x, the value of x is 8. So that's one of the values of an array, and they're indexed. It's viewed as a single list. It's common to use a loop to go through and do something to all the numbers of the array. You want to give everybody an extra credit grade at the end of the semester to kind of level out those grades. You might use a loop for that. I would love to use a loop for that. So I have to go click, 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 click. It's nice to be able to loop through. I think I'll do that though. They know our secret. All right, stack. A stack is an array of sorts, except for there are some functions specifically designed for a stack that operates in a LIFO strategy, like last in, first out. So a stack operates functions. There's a peek, push, and a pop. All right. So if I have my list 2, 4, 6, 8, 10, 12, peek will look at the first at the top of this stack. It'll look at it. It'll give me that value. I now know that this is a 2. I can take that 2 and put it inside of x or something like that. Peek just looks at it. Pop takes that 2 off the top of the stack. I can still do stuff with that 2, but it's no longer on that stack. The new top of that stack is 4. So if I were to peek after I pop that 2, what I would see is 4. Push, put something on the top of the stack. So push with the 2 back here. All right? So it's like a stack of records, if we don't have records here. A stack of plates, a stack of pancakes, stack of cars. There we go. I normally say cars for sorting and whatnot, but a stack of something that's on that goes up on the top. Pancakes. Legos. Legos, yes. Works very well with Legos. Similar to a stack is a queue. It also has peek, push, and pop. However, they might be defined a little bit differently. So with a queue, they look more like draw a queue. A queue. If I put something into a queue, if I push something into a queue, it goes here. I push something else into the queue, it goes here. If I push something else into the queue, it goes here. If I pop something off of the queue, though, it takes the first value. So this is first in, first out. Right? So if I pop, I'm going to take this 2. My new first value will be 8. I push from the back, I pop from the front, I peek at the front. So peek and pop operate here. Push operates back here for a queue. So array, stack, queue, and a linked list. Okay. All right. Release. A linked list is not in contiguous space and memory. Linked list can happen all over the place. A linked list might have the first member, which is called a node. The node has its value, might be 8. but it also knows the location of the next value, the next node in the linked list. So it might know that this one is at location X, and point to that location. Over here is node number 2. It also has its value, and it knows where the next node is in the list. Might be at location Y. Go down here, which knows its value, and the location of the next node in the list, and so on and so forth. So when you're working with a node or with a linked list, it's easier to, it's more agile in regards to the fact that it can grow. If you create an array of a specific size, that array is now that size. If you need to add something to the array, hope you haven't reached the maximum size, otherwise you have to create a new array and have everything move into the new array. That's just tedious. Whereas with a linked list, if you need to add something to it, you just add a new node. You tell this one what the new location is, and you add a new location. So nodes are able to grow. But they're not contiguous in space. So that's one thing. There are 2 important things to know when you're dealing with nodes. One is that you never let go of the first node. You always have a variable that holds on to this particular location. You lose this, then the rest of this path goes away. Right? So if you're creating something and you're dealing with a linked list, and you want to call it your first one heads. That's the head of your line. You don't ever want to change the head. Leave it alone. Don't do anything to it. Don't modify it. You can use it, so don't want to change it. You want to keep track of this node. Another thing is, if you're moving through your linked list, if you're going through this one and you're doing something to this one, and you're going to go to this one and start doing something, don't let go of this one until you already have this one. Already have a place in memory for this, give it to a variable, name it, identify it, something, have it before you let go of this one. So for instance, I might have int x, or let's say, oh yeah, we'll call it x for now. Nope, we'll call it y. Y. All right, so I have y, I'm doing stuff to y. Now I want to go on to the next one. I do not want to say y equals something else, because now I've lost y. I don't have it anymore. I need to create z first, do something with z, then on my next pass I can say y equals something else. I want to keep track of the next one. I always want to keep track, have this one until I have that. Then I can let go of this one and use that variable again. I can let go of this one, use that variable again, and so on and so forth. But you never want to let go of that. You never want to let go of your head. Binary trees. Binary tree also has nodes, but it knows more information. It has its own data, but it knows the location of 2 children. Child node over here and child node over here. It knows that information. And this node has information for 2 of its children. Like that. So binary tree operates in this fashion. If a binary tree, like this one I'm currently creating, is full, which means everybody has 2 kids at every level, that's called a full tree. However, you can have somebody that's like this, and that's still a complete tree. It's still a complete tree. It's still a complete tree because it's not full at the bottom. So it's complete, it's just not full. Full means that every level has everybody that it needs. Complete means that every level is full. Every level has got what it has. There's no parts, but it may not be. The bottom level may not be complete. Every level except for the bottom level can be complete. So complete, full. The first node is called the root. Any node that does not have children is called the leaf. So root, leaf, full, complete. Success. Child, child, also child, child. Yeah. Don't have one binary tree. Thought I did. I probably did. Didn't actually make the link. So again, an array that says, or create an array, return an array, contain the first 3 digits of pi. So at some point at the bottom, you should have something that says return whatever your variable name is for your array. You make an array called x, return x. Also, of notes, when you make a method, if your method is going to return something, so you give a value back to the program that called it, something like that, it'll have the type that is going to return at the beginning of the method. So because it says public int array, this is an integer array, that means that when I'm done, I have to return an int array. I need to have a statement that says return an int array, whatever my integer array is called. If I'm not returning anything, instead of that value, I'll put void. I'll say public void make pi for not returning. Returning something, I tell you what kind I'm returning. I can check this.
Send to 0, we indicate the index position.
No. Very mission.
Clear got Exodus.
Yeah.
You go $5.
Job.
All right, so you gotta go ahead and bracket.
X equals new in bracket size. You can also do in bracket X equals curly brace, read comma 1, comma 4, curly brace. Brace. So do the X equals. That semicolon in, so that way you can get rid of the first line and all those assignments. So if you know what the value is going to be to start with, fix them for some context.
So, because I didn't do this training, I was trying to change the double. So these double lines right there,
Rate.
make comments, so the compiler doesn't use it. Everything that's behind those 2 slash marks, right, is just for the program. We'll talk about comments.
Can you make it a little bit bigger?
Yeah.
Please? Thank you. But, I can't actually see it.
So this line, let's comment it out. Sorry. So no after return value. I can declare that value was, then assign things to each of the elements of the array. Say x 0 is the first position in the array. 2, 3. X 1 is the second position in the array. 1. X 2 to 4. If I do that, that will create my array for me. Oh, I'll just have to say how big it is. Here. So how big the array is going to be. So I do that, or that line comments out. Say, and it's x equals 1, 3, 1. So that line will replace those previous 4 lines. Let's sorry. All right. Algorithm searches source. Algorithm. Clearly defines a set of clearly defined steps that solve a problem. Your algorithm might be a small portion of code. It might be your whole program. Whatever it is, it's a set of steps that solve problems. Big problem, little problem, doesn't matter. Find algorithms in math often, but they exist in a lot of different contexts as well, just like the science context, yeah. So for algorithms, it's important for programmers to build something that's efficient. Like we always want our code to be efficient. We want it to run quickly and smoothly. We don't want to waste a whole lot of space. We know that storage space is at a premium, and we don't want our program, our app, our game, or whatever it is we're creating to be a memory hog. So we create things that are efficient. However, some algorithms are just going to take time. They're going to take a certain amount of time. The way we measure that is with BigO. BigO is a notation system that measures the amount of time certain algorithms take. Some of the common notations are O1, which means it's going to go one iteration, then it's done, one process cycle. Or O log n, where n is the number of items that are being processed. And then you get another that's n log n and n squared. So these are bigger numbers, longer time. So searches are common algorithms. We often have to search through something. Go through a list and find a particular number or do something to the entire list, things like that. A linear search, the very simplest search, just goes through all the items in the list. So the length of time for the linear search, the maximum length of time is the big O, is n. So if there are 20 items in the list, the longest it can take me to find what I'm looking for is 20 times going through this list, 20 searches. A binary search operates differently than a linear search. Binary search may have a list that is going through. Also, important to notice, for a binary search, the list has to already be sorted. In order for a binary search to be used, it has to already be in order. So it will already be 1, 2, 4, 7, 9, 12, 13, 20. Already in order, least to greatest. The binary search, say I'm looking for 9. Another one. Okay. Let's not look for 9, let's look for 13. All right, so I'm looking for 13. Binary search will go to the middle of the array. Say, is that 13? No. Is it bigger or smaller than 13? Smaller, which means I can get rid of everything over here. I don't care about that anymore. Now I'm going to go to the middle of my new array. And say, is that 13? It is. I'm done. It took 2 iterations. Now, sometimes it may take more, but the maximum it'll take is log n. Or that's divide, and then divide, and then divide, and then find the one that's in the middle. So the maximum big O for a binary search is log n. Then you have sorts. Sorts will take a list and put it in order. So if your list is not in order, you have to sort it first, and then you can search it. There's several different types of sorts: selection sort, bubble sort, merge sort, quick sort, line sorts. They all have their different big O's. The selection sort. All right, so the selection sort is a nested loop that continues through an array and selects the next item to put in the line until the array is completely sorted. So the selection sort, we'll look at the first item in the array, 2. We'll take the 2 and put it up here. So hey, I got a 2. Then we'll look at the next item, it says 14. Is 14 smaller than 2? It's not, then I'm staying with 2. Is 3 smaller than 2? It's not, then I'm staying with 2. Is 7 smaller than 2? It's not, then I'm staying with 2. Is 9 smaller than 2? It's not, then I'm staying with 2. All the way until it gets to 1. Is 1 smaller than 2? It is. Now I have a 1. At the end of the array, I put a 1 here. Start over again. Start with a 2. Is 14 smaller than 2? It's not. 2 is my smallest number. Go here. Start with 14. Move over. Is 3 smaller than 14? It is. Switch to 3. 7 smaller than 3? No. 9? No. 3 goes next. It goes through this over and over and over again until the list is in order.
Yes, it removes the 1 and the 2.
Hmm?
Does it remove 1 and 2?
Yes, it ignores the number. We're 1, we're 2, we're done with this. All right, so that's a selection sort. The bubble sort,
So does it always start back over at the far left that hasn't been removed?
that hasn't been removed, yes.
So we'll start over with 14.
Then it would start with 3 and 7.
Well, 3 ought to be removed.
Yes.
So,
Then I'll go to 7. Well, then I'll go start with 14 again.
yes.
Go to 7. And the way these sorts, so I'm going through them logically, but the way this is done is with loops. So there'll be some for loop with some algorithm that does this. Like I said, remember we talked about the bottom up? There are selection sorts that are already written, and insertion sorts that are already written, and bubble sorts that are already written. But it's important that students know how to write these. When we get to the bottom, we'll do another con that starts off with the real basics of just how can you swap numbers, and then swap them. And then eventually you'll be able to grow into the point where you go through a loop that will swap all the numbers and create an entire new array. But we'll see that in a second. So the bubble sort, that's the one that does a lot of swapping.
1, 2, 3, 1.
So the bubble sort tiresome to go through. You can use some deck of cards to go through this to show it in class. But a bubble sort, we'll look at these 2 numbers and say which one is the smallest. This one, okay, well, I'll use this one. Which one is the smallest? This one, then swap those 2. Which one is the smallest? This one, then swap those 2. Which one is the smallest? This one, then swap those 2. Which one is the smallest? This one, and leave that. Which one is the smallest? This one, and leave that. Which one is small? This one, leave that. Which one is small? This one, swap those 2. Then go back and start again. Swapping until it gets to your list and it's working.
So one goes with, has a long bubble sort.
There is a long bubble sort. That's why but they're both of those can be very, very long. It can take a long time. This is why they're big always squared. They could continue to take time depending on how long your list is and that kind of thing. Knowing the big O of these sorts is probably a good idea. Insertion sort, also a big O of N2, uses nested loop to find the best place in the array for an unsorted item. So you may start off with the first thing in the list, you put a 2 here. Then go to 14 and says, well, 14 is bigger than 2, so I'll put it here. Then it goes to 3 and says 3 goes in between those 2. It goes to 7 and says 7 goes in between those 2. It goes to 9 and says 9 goes in between those 2. 21 goes after that one. 24, 36, 1 deserves to be at the front. So an insertion sort also has an N squared, but it has to go through and look at the list and compare it to the new list and put it where it needs to go. So I got to move everybody aside, squeeze it in. The merge sorts. The merge sort is kind of like when you do the different cards like this and like those together. The merge sort takes the list. We got 1, 2, 3, 4, 5, 6, 7, 9. Takes the list and divides it in half. Then it takes that list and divides it in half. Then it takes that list and divides it in half. Then it takes that list and sees that there's only 2 sides and it puts them in order. This is 1, this is 36. Good, we got those in order. This one, already in order, great. Now we're gonna put these in order. Fantastic. This one, divided in half, put in order, 9, 21. And take these two and insert them where they go in this list that we have over here. 1, 9, 21, 24, 36. Also done the same thing with this over here. It's already divided them and sorted them into different orders, different pairs of ordered pairs, and then merged them all back together. Merge sort uses the recursive algorithm and takes n log n iterations. And the quick sort. It also takes n log n. The best case is n log n. The worst case is n squared. So it can also take a very long time depending on how you write the quick sort and how you write it.
It's a quick sort. Recursive.
Okay, I thought it was.
It can be. It can be. That's probably a more efficient way to write it, to be the recursive version. Like I said, recursion takes a little bit of elegance and rhythm. That would be nice for shows, but it is can be written better than some of the other sorts. I think that's different sorts. Yes. So I'll show you this Khan Academy, this selection sort. The reason I did this one like this is so that you can see how Khan had set things up. So it's developing, it's getting better as an application, as I guess a course, whatever. They have this here, which is a document, like an educational document, like a text document that teaches you about sorts and sorting that. Then it comes with a challenge of doing some activity. And it scaffolds those challenges and expresses them in documents. So the first challenge would be come up with an algorithm to swap 2 letters or 2 numbers in a particular array. Right? So the way it's written right now, this way is this is fixed. Yes, this one's been fixed. Here's the brush.
And we'll keep it strong.
And so
Yeah, about the example.
so what I bring
I'll give you the example up.
this one.
Yeah, I'm sure what you have. We'll go down the very bottom. There should be a restart, start over.
Yes. All right, there we go. So this does not give me the correct answer. What I want is for my array, which I did as 7, 9, and 4, I wanted to switch the first 2 values. I wanted to say 9, 7, 4. All right, this doesn't do that. This says take array first index, which would be 7, and make it equal to the second index. So now my new array will be 9, 9, 4. If I take the first index and put the second index into that first one, then my first one is now equal to 9. But now if I take the second one and make it into my first one is equal to 9. So if I switch them now, then it's still going to be 9, 9, 4. That's not what I want. So what do I need to do?
Create a temporary.
For the temporary variable. What will I be holding inside of that temporary variable?
One of the index positions you want to swap. The value of that index position.
Oh, this is bar. Bar. Rules. Right. Remember the first one?
Yeah, just do the first one.
Index. Then second index will equal. Well, bar is just one item. sure to find common successful assertion. All right, so now I created a variable B. I took the first index and put it in there, so that's I made B equal to 7. Then I took the second index, first index, and made it equal to the second one. So now index 1 first is equal to 9. And then I made index 2 equal to what my temporary was. Index second is equal to 7. Now I have 9, 7, 4. So that's like the first. Oh, yeah. Yes. So it's like a first step, and then they continue to scaffold it until the challenge down here is to actually implement a selection sort. So I like that as a scaffolding process toward learning how to create searches and so on and so forth. So that, same thing with binary, I believe. Same thing with binary. So you take your array, divide it with 1/2, divide that with 1/2, divide it with whatever your target value is. Again, I like the idea of having them to fix code first before they write code completely from scratch. And look at it, walk through it, and trace it, see what it does. So this is a, I think this is Python. Yes, that's Python. So do searches, you do method. It's going to take you these parameters, the array that's taken in, and target value, minimum value 0, maximum value of array.length. So this is a way to find out what the length of the array is. That's a method that comes with the array class. And it knows what's on the length. So I say array.length, now I know the length of the array. So max is array.length -1. The reason why we do -1 is because the index starts at 0, right? So if the length is 32 items, there are only going to be 31 indices. The first one is 0. So you need to know that particular index. And bars guess turn -1. Primes is an array with all these values in it. Result is equal to do search. We pass do search. We pass primes to do search. So we take this array, send it to this function, and our target value is 73. So we want to find 73. So we take this array, do our binary search where we divide it in half, get rid of the half that's too high or too low, divide it in half, get rid of the half that's too high or too low, divide it in half, get rid of the half until we find our target value. So we want to write a method that does that. Loop. Okay, so the loop. That's a loop that does that. All right. Do that now. Logic and hardware. I think we're getting close to the end now. All right, logic. Logic gates. Logic gates occur in many situations, many places. They're in philosophy, they're in computer science, they're in economics, they exist in a lot of different places. Electronics, especially. Electronics, yep. Electronic engineering, electrical engineering, right? So it exists there as well. And each one of them has a different set of symbols that they're associated with. So all I remember is the words. I know the words, I know they make sense to me. I know and, exclusive or, and I can draw the tables. These are very useful when you're doing conditionals or loops or things like that.
Here is password. Everybody's in.
So we have not, we have and, we have or, we have exclusive or. We come up with some cool little ways to say, to explain these different ones, like, I can't remember what a cool way to say one of the complicated versions. I think it is. But anyway, all right, so not just means you take whatever you have and you negate it. So your answer is true, you make it false. If it's false, you make it true. Sometimes you'll see it written in Java, I believe it's an exclamation point in front of the variable. So whatever x is, this is the negative version, or not arrows. Yeah. So the exclamation point means not or negate. And I guess you already two days was the same. So I have true, false, true, false, true, true, false, false. So and means that in order for this to be a true statement, both of my previous things have to be the same. Both my previous statements. So that means if this statement is true, this statement is true, and this is true. If this statement is false, this statement is true, it's false. It's a false statement. Both have to be the same. This statement is true, this statement is false, it's a false statement. If both false, still true, because they're both the same. Exclusive or,
Exclusive order. Just have exclusive
I'm
order.
about to say exclusive or, so you set a table the same way, true, false, true, false, true, true, false, false. With or, at least one of them has to be true. At least one. So true, true, that works. Either or, I don't mind it. You got two responsible students. They say, hey, I need to go, somebody to go to the counselor office and get this document. Can we both go? Sure. You both go. I know you'll both go and come back. You're fine. You two actually want to be in class to be blessed. Well, normally your students are exclusive or. We'll get to that in a second. Or the other one might say, hey, I don't want to go. Can I just go by myself? Yes, you can go. That's fine. That's fine. But one of you needs to go. I need the document. I can't leave my classroom alone. Y'all gotta go. It's false. Somebody has to get out and go get what I need you to do. Normally that's not the case though. You don't have those two responsible students that can go together. So with exclusive or, only one of you can go at a time. So can you go together? No, you cannot. Exclusive or means only one can go. So if you can go, yes. Or you can go, yes. But somebody has to go, you cannot go together. Can we both go to the bathroom? I don't see any reason why. No reason why you have to go to get bathroom together. Doesn't make any sense. So exclusive or, and not. And in programming, a lot of times you'll see this. Or on Java, I don't know what.
This JavaScript thing.
JavaScript. Or
There's two
two lines.
same
Like
lines.
that. So, but understanding the logic of it is important because it might
Those of you who don't know where to find that on the keyboard, it's to the right of the curly brace. Shift. Curly brace?
curly braces.
Is that two dotted line?
I can't find it.
Because it's a two dotted line.
Right, from here, the lines, yeah.
Makes no sense.
All right, so logic gates. I did see some of that stuff.
And how do you explain it to the oriented? Only one of you.
Only one can go. Somebody has to go, but only one can go. No reason to send both these kids to the bathroom. They won't come back. They're all over the school, all in the hallways. Wait, stop, stop, I was there when you were talking. No, you didn't. All right, let's see. There were a couple of hardware questions that weren't too in-depth, but you should probably do some review of different things, different parts of the computer, know what peripheral is, know the difference between input and output devices. I think somebody in the last class said they saw a question that said, which one of these things is both an input and an output device? Anybody guess what it was?
Touchscreen. Touchscreen.
Touchscreen would work. Yeah. Another one would be like one of those all-in-ones, printer, scanner, printer that's input and output device. They said a flash drive, which I was a little quizzical about because I've always categorized them as storage. But I guess
I agree with you now. It's like a CD is actually stored.
yes. So technically it could be an input-output device, but man, hopefully they don't put that on the test. It's a storage device.
That's one of those big gray areas.
Yeah. But a touchscreen monitor is definitely input-output. The all-in-one scanner printer thing is input-output. So being able to differentiate between those is important. Knowing what a bus is, it takes the data from one place on the motherboard to another place on the motherboard. Know what the processor is, the brain of the computer, it does all the processing. Portals.
How come that's not on ours? You gonna add it later?
No, yeah, man. I did add it after the fact. I left it blank before. I just really learned this morning. Hardware, most of the hardware stuff we've seen before. I know what an Ethernet cable is. If I want to take this minute off, just do like that. By the way, I had a substitute one day when I came back. Apparently wasn't paying attention because somebody in my class had unplugged all of the Ethernet cables and all the cables from the backs of all the computers in the lab. Where were you at? What were you doing? This. Probably. Know what the ports are, know what the slots are inside the computer. Where you put might put a modem, but we don't use those anymore. RAM, but also expansion cards like you want to expand PCI or a video card or audio card, something like that. You want to do the dual monitor thing, you have one of those cards put in and go into an expansion slot. But yeah, so take some time, review some basic hardware stuff. Won't be a huge consideration, but it's important to know, especially when you're explaining things to your students in regards to not only the programming side of it, but what's actually going on inside the machine. Understand that it's an electrical device that moves electrical signals from one place to another. And there are different components that assist in that, depending on where you need to move those signals. Style conventions. It's kind of written very small, but this is important stuff. So there are some conventions that most languages follow. Not all of them follow the same conventions, but there are some that are pretty consistent. Primitive variables are all lowercase. There's spacing that goes. If you're writing a method, you start your method here, and curly braces here. Next line starts right here. This is spacing convention, and then until you get to the end of that method, and then you go back out again. Helps to organize it, makes it easier to read.
There's most of your APIs help you with that.
So what?
There's most of your, not
APIs. Although, no, APIs is not just written in language.
most of your GUIs help you with.
Yes. Most of your coding environments help you with the spacing convention. When naming objects or variables, use names that describe that object or variable, like can graduate, it tells you what that method is going to do. If this variable represents the age, easy. This helps not only you when you're going back and looking at code, but if your code is being used by some other programmer at some other time, it helps them tremendously. Another thing that helps them tremendously is to make comments. So you'll know that if you do a little slash like this, then anything that follows that slash is a comment. It's not read by the computer. It ignores all of that, but it's very useful to the program. So you want to comment as much as possible, specifically what must be true going into a particular method or process and what you expect to happen when you get done. So if you're writing a method and you say that this method should move a student from their grade to the next grade if they've achieved so many credits, you write that in the comments. That way when they look at the method, they can look and see, is this method doing what it's supposed to do? Whereas if there are no comments and a new programmer looks at your old code, now they got to figure out what you were writing for and why. And that's just a whole lot of wasted time and aggravation, and somebody is saying bad things about you and you don't, you're not even there. See, all primitives are lowercase, all constants are uppercase. Methods start with a lowercase letter, then any other word in that method is uppercase. So you see when I wrote them, I would write something like can graduate, like that. So a method will start off with lowercase, and then any new words in that method will be uppercase. Classes start with capital letter, like student here, start with capital letter. So those are some style conventions that some languages are more strict with, like you can't go outside of these style conventions, it's mandatory. Some of them are more flexible, but you should still do it because, you know, it's how we program and how everybody stays on the same accord. We have to point out, don't teach, so that might be, oh, notation. All right, so you're asking me what languages you might see in the real world. Well, above anything else, especially on like test or anything like that, you should definitely know pseudocode, which means it's not going to be written in Java. It's not going to be written in Python, but it's using the same structures that we've talked about. It uses if, else statements. It uses loop. It may use, say, for loop, or this condition until it reaches that condition. So pseudocode, you should be able to walk through, read through it, and find out what the answer should be, what the output should be. Brackets, no, I don't know how to pronounce that. Brackets, has the little brackets around everything. I've not seen that personally a whole lot, but apparently we use it quite a bit. I've seen syntax diagrams like this. Don't use it much myself, I'm more on this, but this helps to keep the logic of your program going and see which direction things are flowing in. And if you have a conditional or something like that, where there's a loop that you write in here, you can structure it before you actually do the coding to help you see it and understand the program. So those are good examples of notation. I think that's it. I'm putting it for every statutory classes. Let's go. All right. So I think everybody has. Oh, let's see where we at. This is an API. So you can always, if there's a class that already exists and you want to know what are the methods in that class, what are the attributes of that particular thing, for instance, an array, which is an object that's already made, maybe new one. You can type in array API and it'll bring you to something that will describe everything that's going on. So this is the array API. We have the array constructors. So this one has no parameters, no arguments. This one takes a number. This one takes an object, puts some things in an array. This one takes the length of the array. Gives you an example of how to write it, what it looks like. And we also have, let's see, the array has a length, we know. So these are some of the attributes of an array. Array has a length, knows its length. Concatenate is a method of the array, which means you take two arrays and push them together. So it'd be useful to know that you can do that with an array. The API tells you where that is. So for a lot of the methods, string method, for the string methods, things like that that you see often, you can type in the API and go and look and see what methods are available for that particular class, string class. You're going to see what methods and what aspects are available to the class. So that's useful to know. What's this? Oh, we were talking about the pathway assessments. Most schools have options. I like having options. There are some schools that are really interested in their students having an industry level certification when they get done, which is important, which is why it's nice to have the Sundial option or even the MTA software option. Other schools would like to have it in the pathway assessment that is more mindful of the fact that these are high school students. So the NOCTIs tend to be more high school student oriented. I think it depends on which your school is, is choosing to use, NOCTI to study at, or I believe they do. You click on this. This, by the way, is on the Go website.
By the way, MTA is offering training this year.
Nice.
It used to only be C#. This next year will be the first year we started over there. We're doing Python. They're starting as an EPA.
Okay, so does that mean that somebody's doing the walkthrough for that?
Don't know, but also geometrics practice tests are now bundled. So if you're doing MOS testing, you'd actually have geometrics testing for the MTA with it. Part of the 500.
Oh,
test.
yes, I didn't know that. So normally you get a allotment of 500 tests that we normally use for MOS. Now they're extending that to a lot of our computer science tests.
So geometrics now has the practice tests for both C# and Python. Will be part of it too. So they should actually take the practice test to prepare for it. So it's like,
Nice to know. Would you see that to me?
Yeah.
Sure.
um,
On the bottom.
Right.
Oh. It's good old damn blueprint there. This. Hope this anything works. Alright, so this is the NOCTI blueprint for science. We have the area that they're covering. So, analyze programming solutions, design program solutions, code programs, test programs, maintain programs, lead documentation, technical writing, general information and concepts, some sample questions. Performance assessment. So it's got a little bit of stuff in there. Not a whole lot, but so there's some valuable information about the pathway assessments. I talked to you all already about the EdWeb. So who else is going to? Oh, possibly. So EdWeb, you type in computer science, high school, Georgia, type in Godot, GADO. Let's see. All right, something else to point out, you go to the Godot website, so to the homepage. Let's go to the page. Click on Learning and Curriculum. On the right side, you'll see Computer Science. My page, that's my name, Brian Hutz, I'm a Computer Science Program Specialist. I also have links to the EdWeb communities over here. I have some stuff on the side over here. I mean, it's probably going to end up changing and going away. I'm taking this list and some of the stuff I have here. I'm going to create a separate site that makes it easier to search and align materials with appropriate grade bands, both in school and out of school material, curriculum, that kind of stuff. So it'll probably go away from here at some point eventually. I have some information about we can get the endorsement at. I have a link to the University of Texas Austin, that edX course, which I got a lot of my information from. I also have a link to Teals in case any of you all are interested in using Teals. I know the CAB is using them. Teals is a Microsoft arm. They're not really Microsoft. They are Microsoft arm, where they pair an industry professional with a new computer science teacher. So they'll come into your classroom and work with you for a year or so, a year or two, until you feel comfortable with the concept or content. It is. Teals is right here. The coordinator of our area, her name is Tracy Wilson, I believe. But this will take you to their website. If you email me, I can put you in contact with her. So we're doing the endorsements. A couple of resources, most of them already over there. Let's see what else. Oh, yeah. One of the resources we have is Georgia Virtual Schools. So if your school happens to not have a computer science person, which fortunately all your schools do, if they happen to not have one and the students wanted to take a computer science class, they can still take it through GABS. They would sit in someone's classroom, be on a computer, and the teacher would walk through that. In addition to that, the GABS materials are freely available to anybody that wants to use them. So far,
Now, for a student to take that course in your school, there would have to be paid for, so they can do that. Is that right?
if they take it during the school year, it comes through the same FTE. Right. That's what I've been told. Yeah, it comes through there.
The school's got it set up. You're talking individual schools, they teach your gas also on the side.
Our school does the things that, it has to be paid for.
Yeah, to be honest, we have a lab set up where like, we're not gonna do a computer science principles issue, you take and sit in this lab with this person.
Yeah.
Then they tend to give them a assigned class period and it's free for the kid. But most of the time it's, go pay for it, take it on your own. So it depends on
Brian,
the
what did
school
you just click on to get to that page?
This page?
Yeah.
I already had it pulled up, but if you go to
Oh, that's our shared resources. Okay, I see it.
Georgia Virtual. So you see that they have AP Computer Science, AP Computer Science Principles, Computer Science Principles, and if you want to use the materials, it's all here. Really available, click on here, and all the whole course is here. The only thing that's missing is that you don't have the assessments at the end. So that only happens if you're actually signed up for the course.
You don't have access to a lot of the videos. You have to do a secondary step to get.
The videos.
So I had this year, and I also had a kid taking the course, sitting in my lab at the same time. And he did have a whole lot that I didn't have, but I found a piece of paper that I was supposed to send to my administrator and get approval and do all these notes. And it lay on his desk and he told me he was doing everything. But, so you do have to do a little bit, and I don't know if I've ever gotten that paper through, if I've gotten videos on it. But yeah, everything is definitely not there.
Okay. Good to know. So some of the stuff is here.
Yeah.
The scaffold of the course is here that you can make use of. Let's see, what else? Oh, we were talking about some gamification. When my area of research is gamification. We talked about some ways to gamify your classroom. Somebody brought this one up. Playwright. There's some other options for gamified classrooms.
Classcraft.
Classcraft is one. Yeah. Last year I gamified my math class and I just used Khan Academy. I just placed my own structure around it. Whoever spent the most time on Khan Academy per week got a reward. Whoever got the most points per week got a reward. Whenever it's a group of my students, I put them in groups. Reached a certain level as far as points. And that group got a reward. And whatever class I had, they got the most points in class. By the midterm, got a pizza party. So it was individual motivation, group motivation, class motivation. They seem to like that. Kids. I already talked about this book. It's useful. I like it. Online. Go to that. Yeah, so I think that's pretty much all I have. Anybody got any questions, comments, concerns?
What was the gamifying ones again?
Classcraft?
Classcraft is, based around,
Like Avatar,
Avatar type stuff. Not the movie Avatar, but,
Yeah.
sorcery type stuff.
What was the other one?
Classcraft.
What was the other one?
Oh, this one?
Yeah.
Playwright.
What was-
Playwright.
Like,
I've had my, this is not necessarily good at design, but I've had my godkids this summer on Habitica, which is an app. And on the app, you can type in what are your habits you want to focus on, and what you do every day, and your to-do list. And as you accomplish things, you click on it, and it gives you more experience points. Your avatar levels up, you can get a new sword or a new suit of armor or things like that.
What is it?
It's called Habitica. H-A-B, habits, Habitica.
I see it. Vineyard, Tika. Yeah, so,
Let's see, what else is it about? Anything else, questions, concerns?
the classcraft stuff is free. There's points and papers. Hey, stuff is kind of neat, you can put quizzes in.
There's, I think you can do that with this too. I think that's what the primary use of this is to put some little quizzes in, and if they answer the stuff correctly, then it needs to go do something in the world.
My kids liked Brightbot when it came to algorithms.
My pocket's good.
And that's actually really close to what they do on the AP test too, so that was like bonus.
I have a 6-year-old. My godkid's 6, and she loves like. I walk through the door, she's like, ooh, can I code? I love hearing that.
She was what,
Tinker.
which one?
Tinker.
She loves Lightbot and she loves the code, code.org.
Yeah.
Tinker.
Tinker. They have a pretty cool, I put that on their web already. They have a pretty cool curriculum that they just written for the Apple environment, the new Apple environment, the everybody can code thing.
That's
Tinker.
Swift.
Swift, yeah, Swift. Tinker has a new curriculum for that. That was pretty interesting. So here too. But yeah, a lot of this stuff is very cool. This Code Combat is a game that they have to be able to type some code in order to, again, grow their avatar, get better, get stronger. So they walk through a dungeon or fight spiders and whatnot, but they're using loops and conditionals and iterations and that kind of stuff. They're moving forward with that. CS First is a Google curriculum. It's geared, I think, more towards middle school, but high school students can still benefit from it. It's theme-based, so you might have a set of projects that are based on theater, a set of projects based on sports or music or anything like that, but they're all computer science. Huh? That's no, CS First. Codable I like. So far, I want to look at their standards. They have some really cool, well-designed standards. I'm going to be looking to do some standards, statewide standards pretty soon. So I'm starting to key in on additional states that do that standards. Let's see. Everybody knows code.org, HackerRank is pretty good. Code HS, somebody was saying they use Code HS with you. Yeah, it's a large portion of that is free as well. Not all of it, but a large portion of it is free and useful. HackerRank, yeah. And I'll collect all of this and put it on the web as well. Ear Sketch, coding with music. Guts, coding with biology. What's the one with algebra called? I don't know. Bootstrap. Bootstrap. With algebra.
Use the style, use my first one, third word for Bootstrap.
I haven't played with all of them thoroughly yet, but I like the idea of integration. I'm really big on that. I saw a class at Kennesaw Mountain where they took their IDT class and combined it with their 9th grade lit class. and they're on block. So their last block for their first and second semester was this combined course. And a lot of their projects, that they might be reading Romeo and Juliet and then go across the hall and get on Scratch and create a game with a fencing game. You know what I'm saying, or something like that. So it was an impressive course. That was their STEM magnet academy. But I like combining courses like that. I'm real interested in integration. So if you want to check out curriculum, they have a nice one. Centennial Academy. So y'all that are in Fulton or APS, Centennial Academy is integrated computational thinking for elementary and middle school. So like all their classes completely are integrated with computational thinking. That's very cool. They did it on the NSF grant. It's their third year, which they're finally getting it going. The first 2 years were a bit of a struggle. So they probably have a lot to learn, a lot to be learned from them. Who else has some pretty cool programs I saw? I saw a program in Rockdale. Their magnet school, they were integrating IDT and Research One and something else. They had rolled all of it into one class. And they were doing a lot with that. So I like the integration piece. Anything else? Questions? Challenges? Yes.
Brian, what is the specific deadline for gaining endorsement or passing the GACE?
June 2018. However,
Is that concrete or is that
I had to work
subject to change?
I had to work to make that happen.
Okay.
However, and I will edit this off of the live stream. The certification is it's a personal thing. Like you really got to talk to your district about where they are in regards to certification. Because of the 183 districts, only 3 districts have nominated to be status quo, which means they follow all the rules of the state. Every other district is either charter or strategic waiver system. And a lot of them waive certification. I don't know who. That's not that
You know,
I'm.
the 3
So you need to
different
look specifically at.
So what,
3 follow the rules.
which 3? I have to look at the Bible on the document somewhere.
So you guys talk with your administrators, your district.
District leaders,
Okay.
yeah, talk with this guy here.
It's not yet.
Because,
Mandated.
per se, depending on how your district is manipulating their rights to have individual control. So you have to talk to your district about that. The PSC, as a blanket statement, says that in order for teachers to teach a high-level computer science course, they have to be certified after June 2018. They said. However, lots of states have a contract that says if we do X, Y, and Z in order to improve our school system, then we're able to waive 1, 2, 3, 4 of these things over here. And that could be certification, it could be the graduation requirement, it could be, it's all kinds of stuff. Well, not all kinds of things, only 5 things that they could waive. But, so it's a district thing. I would still recommend that you study for and pass the GACE or get the endorsement, something like that. Because 1, I think we should all be qualified computer scientists that are well knowledgeable, and when the parent comes, you say, yes, I'm certified in this and I'm certified in computer science. I think that's an important thing for us to push computer science education forward the way we want it to be.
We're gonna do an endorsement for
Before you do the GACE,
either one will sound like it's.
yes. Either way.
What's the advantage of it?
The advantage of the endorsement?
Price and time.
Well, that's
Well,
disadvantage.
this is
Yeah,
bad.
disadvantage. The advantage is if you are new to computer science, it's probably useful to have a course of study. So where you sit down, learn material, and really dig into the endorsement before you do that. So if somebody has never seen a variable before in their life, I like find somebody to pay for it, go with the endorsement route. If you've been teaching for 2 or 3 years and you're kind of comfortable and you're just a little shaky and you want to make sure that you have all the stuff that you need to have, study up a little bit, take one of those edX courses, go over this stuff here,
Like one of
And
the what courses?
edX,
It
edX
has.
is online,
The UT Austin.
The Texas one,
yeah, Texas one.
it was based off of that.
That 6-week course deal, is that what it is?
Yeah.
Course.
You don't have to take the quizzes because unless you pay $45 to get their certificate, so you literally can just go on there and at your own pace between those 6 weeks, go over the stuff, look at it, and take little mini quizzes, but you don't take the quiz to give you a grade or anything. Unless you
That
pay.
was
Computer
free.
science courses.
That was
Yes.
free.
That's the one for free.
Yeah, I think your name is all the
edX is online. I put a lot of my material up there.
I probably would go to
Yeah.
There's actually a couple of
That's
courses on
like
edX that are very useful. There's,
It's free.
Georgia Tech has Python on there, that I looked at, that's pretty good. The University of Texas Austin has that, computer science, things called computer science foundations, that's what it's called. I think the CS50 is on there, the Harvard one, we have that on there, so there's quite a few. I saw an article once that said, and I put it on the Ed Web, it said 500 or 428 ways you can learn computer programming online. So there's lots and lots of stuff out there. I put it on the Ed Web, so if you want to go back and look at it, you can click on it and look through those, but I haven't looked through all of them clearly. Kind of time there, but
I was telling Brian at the beginning of class that Columbus State University offered an online class this summer for GACE Prep. I signed up for it, I paid for it, it was supposed to start next Monday. I was the only person signed up for it and they canceled the class.
I probably did.
and I lobbied for that class.
It
but I
was
wouldn't talk to you.
$1,200.
Wow.
Oh, well, that's what I answered.
You take the case for mine.
So my
Well,
question
they
is,
suggested that I
no,
take
based on your position,
So,
would you ever go back?
I didn't know.
I don't know what why
Exactly, that's what I'm saying. I'm sitting here like, you took the time to say, yes, but time to like 15 or I'm looking at
Let's see what last year's test was, right? They're not offering, okay, we're testing for things because they're going to be testing, having to take this test by next year that they would make that.
So they're like, here's
Here's my theory. I would like to, whatever, assuming this theory, I would want to sign up class October 1. And then possibly take it again in the winter, like, not February, but December. Because I want to pass, I don't see, you know what I'm saying? And I think that I would take a multi class, take a multi kind of like, these are the struggle days. I don't know. I don't very much. So I would want to know if it was ready to come back over. Although I'm gonna go back and look at all the stuff that I have for that. It's very similar to that test class. It's very, very job.
Yeah, it's a good job. That's why
I just need to check our pseudocode because I have to go, I have to look at that, I'm top programming here. And then they said, no, we don't need that.
I got the big time.
So I needed a refresher over what the latest and greatest pseudocode was, you know, probably the era and all that stuff. I got you.
They're not full-time.
yes, but that's good.
Oh,
That's
yeah.
very good. You know,
But yeah, you can ask them. But if you like set out, I don't know if you set out a message on the same thing that the dates are in.
I figured this out.
Or the check, like, for the end of the day, yeah, the I would even take one in September. Like, I'm so nervous and I have so much anxiety, I can find it. But I will be fine. But I won't freak out until I take it and get that for passing. You are. Yes, yes, you are. That's like when we took a CIW exam, we were all like, and we all passed it. Our only one actually started. But really, it wasn't bad. Like, once the kids were finished with this thing with that, it was hard. I would not, so we all should. Yeah, you're crazy. Can you use a calculator?
No, you have anything in, I think this calculator.
I wasn't sure how. Yeah, because I think Johnson did.
They give you scratch records, if you need one, they'll give you that.
Okay. It's been.
That's a minor, it's a minor choice. Good, done for the day, no all went out at once, because I might. About to, take my granddaughter over to the DMV and
Oh, sorry. They're teachers, a mentor, to work with them. And with the lesson plans with the history. Last year. Look, in that course, he said it was right. I just want to lesson plans for the program. And that is, I'll be happy. Good luck to you.
I think you were, yeah. Thank you. And drive back safely. You too.
So which one do I need to look at?
That's.
Do I go up to the science ones for that?
No, there's different programs, these three here.
Okay,
And
okay.
there are a lot of them are the same. Some of them are a little different.
Okay, so I just did HTML5, okay,
It's I believe that there's somebody that you really want for that. Where they're getting it from, but they're yes.
Right now, my office is HTML5.
Day by day. Where did you teach before? You was great.
It's what I had. It's all that. High school.
Yeah.
I started.
Yeah. That's right. You too. Nice to meet you.
Yeah. I appreciate it. You were, I learned some good stuff.
Natural marriage there. You know.
A lot of like television and a lot of the business teachers, they would lay out the course for you. Actually, specials on all their communities. Do you think we're gonna go, is it next week that they're doing that?
Kansas Justice Society.
No,
I can't have,
They may, I don't know.
yeah, thank you. I love it. Thank you.
Good job, Brian. Good job, man.
I hope I did a good job.
Oh, yeah. Yeah. You too.